Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
हेलो एवरीवन, गुड इवनिंग एवरीवन, हाउ आर यू ऑल? कैसे हैं आप सब? गुड इवनिंग एवरीवन, गुड इवनिंग, गुड इवनिंग, गुड इवनिंग. यस एवरीवन, गुड इवनिंग एवरीवन, गुड इवनिंग, गुड इवनिंग. So dear students, how are you all? Welcome everyone, welcome back. So I promised you that we will meet again at 4 p.m. and then we will be doing the revision of whatever we have discussed in the first half. Yes, okay. So strength of material का रिविजन करना है अपने को, पूरा कंप्लीट अभी नहीं हुआ है, ठीक है ना. सो फर्स्ट हाफ में मैंने आपको बोला था कि कुछ कि सेकेंड हाफ में हम लोग मिलेंगे और इसको हम जो आगे कंप्लीट आगे करेंगे. ना सी क्या क्या हम कर चुके हैं कंप्लीट, राइट. तो ये सारे क्वेश्चंस हम क्वेश्चंस खत्म कर चुके हैं. ये सारे के सारे क्वेश्चंस वी हैव कंप्लीटेड ऑल दीज क्वेश्चंस वी हैव फिनिश्ड. दिस क्वेश्चन आल्सो वी फिनिश्ड. ओके, आफ्टर दैट वी आल्सो फिनिश्ड द प्रिंसिपल स्ट्रेस एंड स्ट्रेन आल्सो, and then we were at the bending moment concept, that is also almost finished. The bending moment concept, that is also almost that is also finished. All these concepts we have already solved. ये सारे क्वेश्चन हम कर चुके हैं. शेयर फोर्स एंड बेंडिंग मोमेंट में भी ये सारे क्वेश्चन हम कर चुके हैं. ये वाला भी क्वेश्चन हमने कर लिया था, ये वाला भी क्वेश्चन हमने कर लिया था, ये वाला भी कर लिया था हमने क्वेश्चन, ये वाला भी हमने कर लिया था क्वेश्चन. ओके, ये वाला क्वेश्चन भी हमने कर लिया था, ये वाला क्वेश्चन भी हम कर चुके थे, ये वाला भी हम कर चुके थे. ओके, आफ्टर दैट वी सॉल्व दिस क्वेश्चन आल्सो. Okay, this is a very easy question. You can solve this question. Okay, a simply supported beam of length L or length 2 meters. Okay, it is subjected to what? It is subject to this much. So ultimately आपको करना क्या है? यहाँ पे आपको यहाँ पे एरिया निकालना है. उस एरिया से आपको क्या मिल जाएगा? उस एरिया से आपको लोड मिल जाएगा और आप अल्टीमेटली इसको सॉल्व कर सकते हो. अगेन इट इज अ वेरी इजी क्वेश्चन ऑल्सो. ये आप जो है इसको इंटीग्रेट भी कर सकते हैं फ्रॉम 0 to 2. तो आपको जो है लोड की इंटेंसिटी पता चल जाएगी और फिर आप वहां से इस क्वेश्चन को सॉल्व कर सकते हैं. लेट अस मूव टू नेक्स्ट क्वेश्चन. ये क्वेश्चन भी बहुत ही सिंपल है. पूरे बीम में जो एम मोमेंट एक्ट कर रही है, राइट. तो पूरे बीम में अगर एम मोमेंट एक्ट करे तो डिजाइन बेंडिंग मोमेंट क्या होगी? एम ही होगी आपकी. और आपका जो शेयर फोर्स है, शेयर फोर्स क्या होगा? एम बाय एल हो जाएगा. सो आपका 2 आपका करेक्ट आंसर हो जाएगा. इसमें कुछ करने की जरूरत ही नहीं है. आगे चलते हैं. ये शेयर फोर्स डायग्राम वाला क्वेश्चन है, ये भी आपका बहुत इजीली सॉल्व हो जाएगा. इसको भी टच नहीं करेंगे हम लोग. जो इजी क्वेश्चन है वो हम सॉल्व नहीं करेंगे. नाउ लेट अस स्टार्ट विद द न्यू चैप्टर दैट इज कॉल्ड एज द बेंडिंग एंड शियर स्ट्रेसेस इन बीम्स. इस चैप्टर से भी हम लोग स्टार्ट करेंगे बेंडिंग एंड शियर स्ट्रेसेस से. कुछ क्वेश्चन सॉल्व करेंगे इस चैप्टर के और फिर हम लोग जो है आगे मूव ऑन करेंगे इस पर्टिकुलर चैप्टर में. सो लाइक एंड शेयर एवरीवन, लाइक एंड शेयर एवरीवन. ओके, यू ऑल्सो शेयर विद योर सम अदर फ्रेंड्स ऑल्सो. ओके, उनके साथ भी आप शेयर कीजिए ताकि उनको भी पता चले कि हाँ स्ट्रेंथ ऑफ मटेरियल का रिवीजन सेशन चल रहा है, क्वेश्चंस वहां पे सॉल्व किए जा रहे हैं, सो दैट द अदर पीपल दे आल्सो कम आउट टू नो. सो नाउ लेट अस स्टार्ट विद द क्वेश्चन डायरेक्टली. सो द फर्स्ट क्वेश्चन, इन द डिजाइन ऑफ बीम्स फॉर अ गिवन स्ट्रेंथ consider the conditions of economy of use of the material would avail as follows. Rectangular cross section is more economical than the cross section. Okay, cross sectional than the square cross section of the same cross sectional area of the beam. Circular section is more economical, या फिर I section is more economical than the rectangular section. Try to give me answer of this question. I will wait for 2 minutes. Otherwise, obviously, I will be giving the answer of this particular question. What will be the answer of this particular question? Now see whether a particular, let us understand the concept. Let us understand the concept first of all. Then you can easily calculate. The concept is that economical. If somebody is saying that a particular section is economical and somebody is saying that one section is not economical, I told you that you just have to calculate the modulus, the section modulus Z. That is your M, that is your I by Y. You just calculate this value, that is your I by Y. जिसकी ज्यादा वैल्यू आ जाएगी, जिसकी Z की वैल्यू ज्यादा आ जाएगी, that is a more economical section. Okay, जिसकी Z की वैल्यू कम आएगी, that is a less economical section. What is the meaning of economy? Economy means that it is providing you sufficient strength, but the material used is less. That is the meaning of economy, right? कि material कम use हो रहा है आपका, लेकिन आपकी sufficient strength आपको मिल रही है. That is called as the you can say that is called as the economy of a particular section, that it is giving you sufficient strength but the cost is not very much. That is the meaning of economy. Okay, so can anybody give me the answer of this particular question? I am waiting for the answer. Let me again move forward to the question. This is the question, right? So if you remember, I told you one thing when I was teaching you the strength of material portion, that the modulus of the section modulus of circular section, okay, it comes out to be less than the section modulus of the rectangular section. So from here we get this concept that the rectangular section is more economical than the circular section, So this is number one result that you should remember, that a rectangular section is more economical than a circular section. Why? Because the section modulus of rectangular section comes out to be more than that of the circular section. This is my point number one. Point number two is that now if you look at the options given, circular section is more economical than rectangular section. So it is completely incorrect because that contradicts what we already know. It contradicts that. It means that the correct answer will either be 1 or either be 3 or both. Now look at the options. In the options we have 1 to 3, 1, 2, 2, 3 and 1, 3. It means that at least 2 options are there, but 2 is incorrect, right? So the correct answer will be what? 1 and 3. That is your 4 will be the correct answer of this question. So this will be the correct answer of this question and it is an important question, dear students. The question is, sir, ये तो आपने option को eliminate करके मेरे को answer बता दिया, क्या मुझे बिना क्वेश्चन को बिना आंसर को एलिमिनेट करे मुझे आंसर नहीं मिल सकता? तो रिप्लाई होगा कि आपको मिल सकता है आप आंसर, लेकिन अल्टीमेटली व्हाट यू हैव टू डू इज दैट यू हैव टू कैलकुलेट द सेक्शन मॉडुलस. अगर आप सेक्शन मॉडुलस निकाल सकते हो तो फिर तो कोई दिक्कत वाली बात ही नहीं है, लेकिन अगर सेक्शन मॉडुलस निकालने में अगर आपको प्रॉब्लम आएगी तो फिर आपको प्रॉब्लम वाली उसमें बात है. ठीक है. तो सेक्शन मॉडुलस हम कैसे निकालते हैं? आई बाय वाई. तो मान लो कि रेक्टेंगल है आपके पास, दिस इज योर रेक्टेंगल विद यू, दिस इज माय बी, this is my D, like this. Okay, the section modulus comes out to be what? Of a rectangular section, it comes out to be BD cube divided by 12 and divided by D by 2. Y is what? The distance from the topmost or the lowermost fiber from the central axis, that is the centroid, that is your Y by 2. Ultimately it comes, so not Y by 2, that is your D by 2. It comes out to be ultimately BD square divided by 6. The section modulus of a rectangular section about this axis. About this axis will be what? DB square divided by 6. Similarly, for a circular section also, if you want to calculate the section modulus for a circular section also, the section modulus comes out to be equal to what? It comes out to be pi d raised to the power whole 4 divided by 64 into radius divided by, that is D by 2. It will ultimately come out to be D cube divided by what? It divided by 32. D by pi D, yes, it is pi D4 divided by 64 divided by D by 2. That will come out to be your Z here. So you have got the value of Z here also, you have got the value of Z here also. Now with the help of some फॉर्मूले व्हाट यू हैव टू डू इज दैट कि आपको देखना पड़ेगा कि एक रेक्टेंगल अगर मैं इसके बीच में लगाऊंगा तो उस रेक्टेंगल का एरिया, उस रेक्टेंगल का डायगोनल कितना होगा, ये कितना होगा, वो कितना होगा, और अल्टीमेटली आपको समझ में आएगा कि जो सेक्शन मॉडुलस जो रेक्टेंगल का आता है वो हमेशा ज्यादा आता है सेक्शन मॉडुलस ऑफ सर्कल से, एंड दैट इज व्हाई द रेक्टेंगल इज मोर इकोनॉमिकल एज दैट ऑफ सर्कल. सो वेरी सिंपल. लेट अस डायरेक्टली मूव टू द नेक्स्ट क्वेश्चन. दिस क्वेश्चन, हु विल सॉल्व दिस क्वेश्चन? हु विल सॉल्व दिस क्वेश्चन? इस क्वेश्चन को सॉल्व कीजिए जरा. हु विल सॉल्व दिस क्वेश्चन? इस क्वेश्चन को जरा सॉल्व कीजिए. ओके, क्वेश्चन जरा पढ़िए, बड़े ध्यान से क्वेश्चन को पढ़ो. आप जरा क्वेश्चन को पढ़ो और क्वेश्चन को थोड़ा पढ़ने का, थोड़ा समझने का ट्राई करो. राइट, जस्ट ट्राई टू अंडरस्टैंड द क्वेश्चन. आपको समझ में आ जाएगा क्वेश्चन का मतलब क्या है और मुझे कैसे इस क्वेश्चन को सॉल्व अल्टीमेटली करना है. हाउ डू आई हैव टू अल्टीमेटली सॉल्व दिस पर्टिकुलर क्वेश्चन. एक बार इसको पढ़ो और समझने का इसको ट्राई करो. A simply supported wooden log AB of length 4 meters carries UDL as shown in the figure. Okay, correct. Find the maximum bending stress. So we have to find the maximum bending stress in beam if the cross section of the beam of the rectangle is of width, some width is given and some depth is given. तो आपको bending stress निकालना है maximum. सो मैक्सिमम बेंडिंग स्ट्रेस कैसे निकलेगा, ये आप जरा एक बार थोड़ा दिमाग लगाओ अपना। मैं आपको 2 मिनट का टाइम दे रहा हूं, आप थोड़ा सा अपना दिमाग लगाओ और आपको जो है इसका आंसर मिल जाएगा। ठीक है, चलिए अपना दिमाग लगाइए आप इसमें, कैसे निकलेगा बेंडिंग स्ट्रेस। सो बेंडिंग स्ट्रेस कैसे निकलता है, इट कम्स फ्रॉम द फ्लेक्सुरल फॉर्मूला, राइट। फ्लेक्सुरल फॉर्मूला जो हमारे पास है या बेंडिंग फॉर्मूला, वहां से हम लोग बेंडिंग स्ट्रेस निकाल सकते हैं बहुत ही इजीली। ठीक है, तो आप निकालिए अपना बेंडिंग स्ट्रेस, क्या निकलेगा इसका बेंडिंग स्ट्रेस, जरा निकालिए एक बार जरा। आई एम वेटिंग फॉर द आंसर्स, आई एम वेटिंग फॉर द आंसर्स। निकालिए अपना आंसर, क्या आंसर होगा इसका, जरा बताइए मेरे को क्या आंसर होगा इसका। व्हाट विल द करेक्ट आंसर टू दिस क्वेश्चन, बताइए जरा एक बार। क्या आंसर होगा इसका, जरा बताइए। वेटिंग फॉर द आंसर्स, वेटिंग फॉर द आंसर्स डियर स्टूडेंट्स, आई एम वेटिंग फॉर द आंसर्स। आई एम नॉट फीलिंग वेल बट स्टिल। क्या आंसर होगा स्टूडेंट्स का, जरा बताइए मेरे को। बताइए जरा, बताइए। बहुत ही सही क्वेश्चन है, राइट। थोड़ा सोचो समझो, थोड़ा सा आपको आंसर मिल जाएगा। ये ग्रेड के लेवल के क्वेश्चन है डियर स्टूडेंट्स। सो ये ऐसा नहीं होगा कि आपको बस तुक्का मारो और आपका आंसर आ गया। नो, इट विल नॉट बी लाइक दिस। सो यू हैव टू अंडरस्टैंड इट वेरी केयरफुली, देन यू विल गेट द आंसर ऑफ दीज क्वेश्चंस। ओके, आप थोड़ा समझिए इसको, आपका समझ में आ जाएगा। बताइए इसका आंसर क्या होगा। वेटिंग फॉर द आंसर्स। नोबडी इज गिविंग मी द आंसर, नोबडी इज गिविंग मी द आंसर। किसी के पास आंसर है ही नहीं क्या? बताइए इसका आंसर क्या होगा। ओके, समीर इज सेइंग 8.9 to 8 के आसपास, समीर इज सेइंग दैट। ओके, व्हाट अबाउट अदर्स, बाकी का किसी का आंसर आया, बाकी किसी का आंसर आया, राइट। सो देखो, जब भी हम बेंडिंग स्ट्रेस निकालते हैं फ्लेक्सुरल फॉर्मूले से, उसका बेस क्या है, उसका व्हाट इज द बेस ऑफ द बेंडिंग स्ट्रेस, राइट। सो वी ऑलवेज कैलकुलेट द बेंडिंग स्ट्रेस इन केस ऑफ प्योर बेंडिंग, राइट। सो देव सिंह रावत का भी 8.92 के आसपास आ रहा है। वेरी गुड, बहुत बढ़िया। ओके, मैं निकालता हूं, मेरे को पता नहीं इसका आंसर क्या है, मैं को निकालूंगा, देखता हूं आंसर सही आ रहा है कि नहीं आ रहा। सो बेंडिंग स्ट्रेस का जो सोल फॉर्मूला है या जो सोल कॉन्सेप्ट है, इट इज जस्ट दैट we should have a pure bending in our beam। अब प्योर बेंडिंग का मतलब क्या है, प्योर बेंडिंग का मतलब मैं आपको फर्स्ट हाफ में अच्छे समझा चुका हूं कि प्योर बेंडिंग का मतलब क्या होता है। ठीक है, चलिए फिर भी इसको निकालते हैं अभी। देखिए, क्वेश्चन इज दैट अ सिंपली सपोर्टेड वुडन लॉग AB of length 4 meter carries a UDL as shown in the figure। So this is a figure given और यहां पे अपने को कुछ दिया हुआ है कि ऐसे से UDL एक्ट करता है, whatever it is। Okay, find the maximum bending stress। अब मैक्सिमम बेंडिंग स्ट्रेस मुझे निकालना है। सो मैक्सिमम बेंडिंग कैसे स्ट्रेस कैसे निकलेगा, मैक्सिमम बेंडिंग मोमेंट से। इससे सिंपल क्या होगा, राइट। ओके, और एक अगर UDL लग रहा है, अगर किसी बीम में, फॉर एग्जांपल अगर कोई सिंपली सपोर्टेड बीम है आपके पास डियर स्टूडेंट्स, राइट, इफ यू हैव अ सिंपली सपोर्टेड बीम, और अगर उस पे अगर आपके पास एक UDL लग रहा है, तो मैक्सिमम बेंडिंग मोमेंट कहां पे आती है, तो मैक्सिमम बेंडिंग मोमेंट तो सेंटर पे आती है। कितनी होती है ये, WL²/8, दैट इज योर WL²/8। तो यहां से आपको मैंने एक हिंट दे दिया है यहाँ पे। द हिंट इज दैट यू हैव टू गेट द मैक्सिमम बेंडिंग मोमेंट विद द हेल्प ऑफ दिस फॉर्मूला, दैट इज WL²/8। ओके, उसके बाद आप इसको बेंडिंग स्ट्रेस वाले फॉर्मूले लगा दो आप इसको, दैट इज σ/y इज इक्वल टू m/i is equal to E/R। You just put it in this formula। यहाँ पे ज्योमेट्री प्रॉपर्टी की रिक्वायरमेंट है ही नहीं यहाँ पे, तो इसी फॉर्मूले से मेरा सारा आंसर आ जाएगा यहाँ पे। ठीक है, आ जाएगा इसका आंसर। जरा एक बार निकाल लेते हैं इसको, तो जरा एक बार इसको बनाते हैं, इसको बीम को। दिस इज माई बीम नाउ। सो दिस बीम हैज अ UDL। What is the intensity of this UDL? The intensity of this UDL is 6 kilonewton per meter। That is the intensity। That is 6 kilonewton पर मीटर इज द इंटेंसिटी ऑफ दिस UDL। चलिए ठीक है, इंटेंसिटी मिल गई मेरे को, और लेंथ कितनी है इसकी बीम की, 4 मीटर इज द लेंथ ऑफ द बीम। सो ये है आपके पास कितना, दैट इज योर 4 मीटर, सिंपल। सो क्या हो जाएगा आपका मैक्सिमम बेंडिंग मोमेंट, द मैक्सिमम बेंडिंग मोमेंट mmax इज द मैक्सिमम बेंडिंग मोमेंट, दैट इज योर WL² डिवाइडेड बाय 8। क्लियर। तो W कितना है मेरे पास यहाँ पे, W मेरे पास आ गया 6 किलो न्यूटन पर मीटर, राइट, इंटू L²। L क्या है मेरे पास यहाँ पे, L है मेरे पास 4 मीटर्स, 4 मीटर्स मेरे पास L है, ध्यान रखना, यूनिट्स का बड़ा ध्यान रखना, आप यूनिट्स का ध्यान रखोगे तो हो जाएगा, राइट। दैट इज योर 4 होल स्क्वायर, दैट इज योर 4 होल स्क्वायर, राइट, दैट इज योर 4 होल स्क्वायर, राइट, ओके। एंड डिवाइडेड बाय 8, डिवाइड बाय 8, जो आपका आंसर आएगा किस में आएगा, दैट विल बी योर किलो न्यूटन मीटर, द आंसर विल कम आउट टू बी in kilonewton meter. So 4 into 4 is 16, 8 into 2 is 16, 6 into 2 is 12. So 12 kilonewton meter is the correct answer. You can also convert that in the Newton mm also. So that will ultimately come out to be 12 into, अगर आप इसको 10⁻⁶ से मल्टीप्लाई कर दोगे तो किलो न्यूटन का न्यूटन में कन्वर्ट हो गया और मीटर का आपका mm में कन्वर्ट हो गया। आप ऐसे भी कर सकते हो, आपकी मर्जी है आपको कैसे करना है, बट अल्टीमेटली व्हाट इज द फाइनल कंक्लूजन, द फाइनल कंक्लूजन इज दैट यू हैव गॉट द मैक्सिमम बेंडिंग मोमेंट। ये मेरा फाइनल कंक्लूजन है कि आपको मैक्सिमम बेंडिंग मोमेंट मिल गया। अब मैक्सिमम बेंडिंग मोमेंट मेरे को मिल गया तो क्या मैं इसको डायरेक्टली फ्लेक्चरल फॉर्मूले में लगा सकता हूं? हाँ जी, क्यों नहीं निकाल सकता, तो मैं लगा ही सकता हूं। तो चलिए आगे बढ़ते हैं इसमें। तो क्या हो जाएगा आपका यहाँ पे सिग्मा मैक्सिमम और द मैक्सिमम बेंडिंग स्ट्रेस डिवाइडेड बाय वाई, और y क्या होगा आपका अपर मोस्ट या लोअर मोस्ट फाइबर से डिस्टेंस, राइट, ओके। दैट विल अल्टीमेटली कम आउट टू बी m by I. If I directly apply in this formula, you will get the answer. So your sigma max will come out to be m into y divided by I. Sigma max will come out to be m into y divided by I. तो क्या मुझे यहाँ पे I पता है? I तो नहीं पता मुझे। क्या क्वेश्चन में दिया है I? एक बार चेक कर लेते हैं। नहीं, I तो नहीं दिया, लेकिन हाँ डायमेंशंस दिए मेरे को। अगर I नहीं दिया बट डायमेंशंस आर गिवन, कैन आई फाइंड द वैल्यू ऑफ I? यस, वेरी इजीली, राइट। The width of the beam is 140, the depth of the beam is 240, right? So what will the value of this I? So I will be equal to 140, that is the width of the beam, into d cube, that is your 240 whole cube, and divide by 12. bd cube divided by 12, you will ultimately getting some I value, okay. Do I know the value of y? Y will be equal to what? Y will be equal to h by 2, simple. What is this y? Y will be equal to h by 2, simple. So if you look at this section, right, if you look at this section, what is the value of y? Y will be equal to h by 2, simple, na, right? So that will be equal to h by 2. H is what? H is my 240. So that is what 240 divided by 2. Ultimately it will come out to be 120 mm. अब ना आपको समझ में आ गया होगा कि मैंने इस वाले क्वेश्चन में यहाँ पे इसको न्यूटन mm में कन्वर्ट क्यों किया, बिकॉज मुझे सारी जो यूनिट्स थी ना वो mm में दी हुई थी, तो मेरे को मीटर में लेकर के अपने कैलकुलेशन को खराब नहीं करना। आई वॉन्ट टू मेक माई कैलकुलेशंस वेरी मच इजियर, राइट। सो अल्टीमेटली इट विल कम आउट टू बी सिग्मा मैक्स विल बी इक्वल टू m. व्हाट इज दिस m नाउ? m is 12 into 10⁻⁶. So 12 into 10⁻⁶ into y. y कितना आ गया मेरे पास? 120 divided by I. Now I कितना आ गया मेरे पास? 140 into 240 cube, 140 into 240 whole cube, and divide by 12. The 12 will go at the numerator. तो अल्टीमेटली आंसर कितना आ जाएगा? मैं कैलकुलेटर यूज कर सकता हूं, डियर स्टूडेंट्स आप नहीं कर सकते, आपको जो है गेट साइंटिफिक कैलकुलेटर यूज करना, राइट। सो इफ आई कैलकुलेट इट, अल्टीमेटली इट विल कम आउट टू बी 12 into 10⁻⁶ into 120 into 12 and divided by 140 and divided by 240 whole cube. Ultimately it will come out to be nearly 8.928. It comes out to be 8.928 megapascals. 8.928 megapascal is the answer which I am getting. What is your answer? What is your answer, dear students? आपका आंसर कितना आ रहा है? आपका आंसर आ रहा है देव सिंह रावत का 8.92, चलिए बहुत बढ़िया। समीर का आ रहा है 8.928, अरे बहुत बढ़िया, सबका आंसर सेम ही आ रहा है, फिर तो बल्ले बल्ले हो गई, हमारी कोई दिक्कत ही नहीं है अब तो आंसर क्या आ गया इसका? 8.928, राइट। द करेक्ट आंसर ऑफ दिस क्वेश्चन विल बी व्हाट? इट विल बी इक्वल टू 8.928 megapascals. 8.928 megapascals. Why megapascals? Because it was asking me find the maximum bending stress in megapascals. So that is why I have calculated in megapascals. So very simple. Let us move directly to the next question. Is it fine? Is it fine, dear students? समझ में आया आपको? Is it fine? Is it fine? आपको समझ में आया? Have you got it, dear students? Have you got it? Like, share and subscribe also, dear students, ताकि बाकी तक भी बात पहुंचे, right? जितना आप शेयर करोगे उतना उनका भी फायदा है और आपका भी फायदा है, उनको भी सीखने को मिल जाएगा, अल्टीमेटली आपके फ्रेंड्स को भी सीखने को मिल जाएगा, ठीक है ना। ओके, चलिए, ये समझ में है आपको? हैव यू गॉट इट? ये समझ में है आपको? सॉरी, आया आपको समझ में स्टूडेंट्स? हैव यू गॉट इट डियर स्टूडेंट्स? समझ में आया आपको? ओके यस, चलिए आगे बढ़ते हैं। नाउ लेट अस मूव टू नेक्स्ट क्वेश्चन. This question. A beam of rectangular section is subjected to a transverse load. A transverse load is acting. Remember this thing, right? Calculate the maximum shear stress in the beam at the 1/3 of the section of the beam. The applied shear stress is in the beam. ये आपका होगा where at the 1/3 of section of the beam the applied shear stress is 120 megapascal. थोड़ा समझने का ट्राई करो क्वेश्चन का कहने का मतलब क्या है. What does it want to convey? Try to understand the question, you will get the answer. A beam of rectangular cross section or rectangular section is subjected to a transverse load. Okay, full stop. Calculate the maximum shear stress in the beam where at the 1/3 of the section of the beam the applied shear stress is 120 megapascals. So that is the question. So question थोड़ा सा ट्रिकी क्वेश्चन, थोड़ा समझो इसको, कैलकुलेट करने का ट्राई करो. आई एम वेटिंग फॉर द आंसर्स. थोड़ा सा ट्रिकी क्वेश्चन है, कैलकुलेट करने का आप ट्राई करो, आपका आंसर आ जाएगा. So you have to find the maximum shear stress in the beam. So एक चीज बताओ मेरे को, where do you get the maximum shear stress? At the center you get the maximum shear stress if you remember, right? So if you remember, this is a rectangular cross section, and if you draw the shear stress diagram also, it comes out to be parabolic in nature, and at this point you get the maximum shear stress. At this point you get the maximum shear stress. और जब हमने solve किया था उस time पे, the maximum shear stress was coming out to be 3/2 times of tau average. और to be more precise आप ये भी लिख सकते हो उसको, that is 1.5 times of tau average. That is what? That is your tau max. 1.5 times of tau average is your tau max. Now something is given to you in question, that is at 1/3 of the section of the beam the applied shear stress is 120 megapascal. That is given to you in the question, by the way. Okay, so that thing is given. Now with the help of that thing we have to find out the answer of this question. Now to be more precise, to further give you one more hint, we know that the shear stress at any section, for example this is a rectangular section, this is a rectangular section, right? If you want to calculate the shear stress at any section, that is equal to what? That is equal to V into A into Y bar divided by I of what? Neutral axis and into B. That is the formula. Now what is this A? A is the area of the strip which we are taking into consideration. याद है ना आपको कैसे करते हैं हम लोग? A क्या करते हैं? A मान लो कि आपने इसका स्ट्रिप का एरिया ले ले, A क्लियर. Y बार क्या करते हैं? सेंटर से लेकर के इसके डिस्टेंस का जो बीच में जो डिस्टेंस, दैट इज योर Y बार. इफ यू रिमेंबर, दैट इज योर Y बार. एंड व्हाट इज दिस B? B is the width of the section. What is this INA? Neutral axis, the moment of inertia about the neutral axis. That is what is INA. So now with the help of these two hints, एक हिंट तो मैंने आपको ये दे दिया और एक हिंट मैंने आपको ये दे दिया, ये वाला. इन दोनों हिंट की मदद से आप इसको इजीली कैलकुलेट कर सकते हो if you want to calculate it, right? So I'm waiting for 2 or 3 minutes. I'm waiting for the answers. मैंने आपको एक हिंट दे दिया है. ओके, देव सिंह रावत बोल रहे हैं 135. ओके, खाक से बोल रहे हैं कि 135. ओके, चलिए इसके अलावा बाकी का आंसर और किसी का आंसर आया आप में से? और किसी का आंसर? 2 बच्चों का आंसर ऑलरेडी आ चुका है. इसके अलावा एनीथिंग एल्स? एनीवन एल्स? इसके अलावा 2 का आंसर ऑलरेडी आ चुका है. इसके अलावा बाकी आंसर? समीर, आर यू वॉचिंग दिस? इफ यू आर वॉचिंग दिस, व्हाट इज द आंसर ऑफ दिस क्वेश्चन? समीर, क्या इसका आंसर होगा? What will the answer? Okay, I'm solving. Okay, try to solve it. I'm giving you some more time. Try to solve it. Okay, Samir is also getting 135. Very good. Now let us try to solve it also. अगर आपका सबका आंसर आ गया तो सॉल्व करने की जरूरत नहीं है, बट फिर भी एक बार इसको सॉल्व कर दे. Let us still solve it, right? So the shear stress at 1/3 of the section. Now look at the hint. The 1/3 of the section of the beam, the applied shear stress is 120 megapascal. So I will say that, let us say that this is your B, is the width of the beam. Okay, the width of the beam is B. At this is your D. The total is D. And this will be what? It will be D by 3. It will be D by 3. So in this thing, the shear stress of the total shear stress is given as what? It is given as 120 megapascal. So it will be equal to what? 120 megapascal should be equal to V, the shear force. Now what is the shear force? I don't know. V into area. Area will be equal to B into D by 3. So B into D by 3 multiplied by Y bar. What is this Y bar? The distance between this to the center. Now if this is D by 3, this will also be D by 3. If this is D by 3, okay, this is D by 3 and that will be what? D by 6. Okay, so ultimately it will be what? It will be equal to D by 6 and plus D by 6. Because if this D by 3, this will be D by 6, because D by 3 plus D by 6 will ultimately come out to be equal to D by 2, right? Okay, so here D by 6 plus D by 6 and divided by the moment of inertia, that is BD cube by 12. That is BD cube divided by 12 and multiplied by B, right? So what is cancel out? B gets cancel out from here. D and D square will get cancelled out from here. This will be 6, or D by 3 it will be equal to D square. So D square, this D will ultimately get cancelled out here. So ultimately what you will be getting is that 120 will be equal to, let me again see this. So here the numerator we will be getting 2 and this will be 6. So 6 it will be equal to 2. Okay, it will be equal to 2 and it will be equal to D by 3. It will be equal to, I guess, 4 by 3. It will come out to be 4 by 3. It will come out to be 4 by 3 multiplied by 4 by 3 multiplied by, now what else is left? So we have numerator V is there. So V divided by BD. Let me again check it. V divided by BD is there or not? So that is 2 is 3 and this is your 4. So 4 by 3 and yes, correct. So V divided by BD. So what is this V divided by BD coming out to be? So the V divided by BD it is coming out to be, that is 4 into 3 is 12, that is 90. So V divided by BD is coming out to be 90 megapascals. So 90 megapascal is the value of the average shear stress. That is the value of, you can say, average shear stress. Now what is my tau max? Tau max will be equal to 1.5 times of 90. So 90 plus 45 will be equal to 135. 135 megapascal, simple. So tau max is what? The tau max is 135 megapascal. Have you got it, dear students? Have you got it? Have you got it? समझ में आया आपको? Have you got it? समझ में आ गया आपको कैसे हुआ? थोड़ा सा दिमाग लगाओगे तो आंसर आ जाएगा, कोई प्रॉब्लम नहीं आएगी आपको. ठीक है, आगे बढ़े. Shall we proceed now? Shall we proceed, dear students? Shall we proceed? What do you say? Shall we proceed now? Okay, yes, चलिए आगे बढ़ते हैं. Let us proceed now. Let us proceed. Okay. Next question. Next question में थोड़ा दिमाग लगेगा. Next question. Try to understand this question. A trapezoidal section subjected to a force of 50 kilonewton as shown. Okay. The maximum bending stress is induced in the section at a depth of alpha meter from the top of the section. The value of alpha is what? Try to understand this question and try to answer this question. इस question में बहुत ज़्यादा दिमाग लगने वाला है ultimately आप लोगों का. So a lot of, you can say, it is a very brain twisting question it is. So here some 50 kilonewton load is applied which is acting in this direction. Let me again draw the figure if you are not able to see this. So here we have this thing. Okay, it is a trapezoidal section somewhat like this. And it is fixed at the base. It is fixed at the base somewhere here. It is fixed. Okay, and here also we have this thing. Okay, here also we have this thing somewhat like this. Okay, and some load is applied in this direction, that is your 50 kilonewton. This is the load which is applied in this direction, which is shown here, that is 50 kilonewton. So what do we have to find is that it is saying that the maximum bending stress is induced in the section at a distance of depth of alpha meter from the top of the section. From the top of the section at a depth of alpha meter, we are getting the maximum bending stress. Okay, The value of alpha is what? What is the value of this alpha? Try to give the answer of this question. This question is a little bit typical. थोड़ा सा आपको सोचना पड़ेगा इस क्वेश्चन में. आपका लेकिन आंसर आ जाएगा. थोड़ा सा भी अगर आप सोचोगे तो आपका आंसर इसमें आ जाएगा. And like, share and subscribe also, dear students. Like, share and subscribe also. थोड़ा सा आंसर लगाओगे तो आपका आंसर आ जाएगा. थोड़ा सा आपका दिमाग लगाना पड़ेगा इसमें. इतना इजी क्वेश्चन नहीं होगा ये वाला. थोड़ा सा आपको आंसर इसमें दिमाग लगाना पड़ेगा इसमें. ठीक है, देखो मैं आपको एक हल्का सा एक हिंट देता हूं यहाँ पे. मैं आपको, लेट मी गिव यू अ हिंट ऑल्सो. और ऐसा क्वेश्चन अगर एग्जाम में आ गया ना, मैं आपको बता रहा हूँ ऐसे क्वेश्चन आने वाले एग्जाम में. ठीक है ना. चलिए मैं आपको थोड़ा सा एक हिंट देता हूँ. मान लीजिए फॉर एग्जाम्पल यू डू नॉट नो दैट एट विच सेक्शन यू विल गेट द मैक्सिमम बेंडिंग स्ट्रेस, राइट? दैट इज एट अ डिस्टेंस ऑफ अल्फा मीटर. इट इज सेइंग फ्रॉम द टॉप. लेट अस से दैट the distance from the top where you are getting the maximum bending stress, let us say it is your some x distance. मान लीजिए कुछ x distance मैंने अलग से ड्रॉ किया है. मैं इसको हटा देता हूँ दोबारा से. let me again rub this because otherwise let me, yes, मैं एक बार इसको यहाँ से ड्रॉ करता हूँ. let me draw it from here. From here. let us say at a distance of x you are getting the maximum shear stress. okay, मैं एक बार मार्कर ले लेता हूँ आपका ये वाला. ठीक है, yes, ball point pen I have taken. I have also taken the ink also. This ink I have already taken. okay, now how to magnify it. Yes, use magnifier. Now let us try to understand this. Now see, in this particular figure, in this particular figure, okay, sorry, in this particular figure, okay, so in this particular figure, let me assume that at a distance of this small x, it can be any distance. At a distance of this small x, I have to find the shear stresses, oh sorry, bending stress at this small x. okay, now what will happen? Now let us understand what will happen. Now let us say that this is your distance x. This is your distance x. okay, let us read the question once more. Let us read the question. A trapezoidal section subjected to a force of 50 kN as shown. So this is the force which is acting. The maximum bending stress is induced in the section at a depth of alpha meter. I don't know where this alpha. From the top of the section, the value of this alpha will be what? So let me assume कि वो x कोई भी distance है जहां पे मेरे को maximum निकालना है stress. Because देखो जब भी ऐसा कोई question आता है ना, maximum, minimum, the only thing that we have to apply is the concept of maxima minima. If you know how to apply the concept of maxima minima, you will not face any issue. Because इस question में इसके अलावा कुछ दिया ही नहीं है. Nothing is given in this question. So obviously we are only left with one option. Apply the concept of maxima minima. But maxima minima concept can only be applied if the expression is in terms of x. Then only you can apply the maxima minima concept. So what is the bending stress formula? That is sigma by y is equal to m by I इज इक्वल टू ई बाय आर. सो दैट इज व्हाट द बेंडिंग स्ट्रेस फॉर्मूला. यही तो है हमारे पास बेंडिंग स्ट्रेस फॉर्मूला, है ना. सिग्मा बाय वाई इज इक्वल टू एम बाय आई इज इक्वल टू ई बाय आर. दिस इज माय बेंडिंग स्ट्रेस फॉर्मूला. अगर ये मेरे पास बेंडिंग स्ट्रेस फॉर्मूला है, ओके, somebody is saying 5 मीटर, somebody is saying 10 मीटर, ओके ओके, कोई 5 मीटर बोल रहा है, कोई 10 मीटर बोल रहा है. चलिए ठीक है, एक बार देखते हैं इसको क्या इसका आंसर होगा. ठीक है, देखिए, तो x मीटर पे अगर मैं x मीटर नीचे जाऊंगा तो स्टार्टिंग में तो 775 mm था ये वाला, राइट. ऊपर जो इसकी विड्थ है ये 75 mm है. तो अगर मैं x मीटर नीचे जाऊंगा, x या x mm नीचे जाऊंगा, तो ये जो मेरे पास एरिया होगा, बिकॉज ये तो इंक्रीज हो रहा है ना, क्योंकि ट्रेपेजॉइड तो आपका ऐसे जा रहा है, तो वो तो आपका एरिया इंक्रीज हो रहा है आपका, राइट. सो अगर मैं x मीटर नीचे जाऊंगा, x mm नीचे जाऊंगा, तो क्या हो जाएगा आपका, ये आपका 75 प्लस x हो जाएगा. वाई? बिकॉज देखो ये 75 है, ये 150 है. इसका मतलब कि ये ट्वाइस हो गया है 10 मीटर में. ये ट्वाइस हो गया है 10 मीटर में, ध्यान रखना इसका. इट हैज बिकम ट्वाइस इन 10 मीटर. द एरिया, okay, the length actually has become twice in 10 meter. So in x it will become x. So it will be 75 plus x. And this will be equal to what? This will also be equal to 75 and plus x. So 75 plus x and 75 plus x is this thing at a distance of x meter, right? अब एक काम करता हूं मैं, मैक्सिमम बेंडिंग स्ट्रेस निकालने के लिए मेरे पास जो फॉर्मूला, दैट इज योर सिग्मा is equal to my divided by I. मैं इस फॉर्मूले में इसको पुट कर देता हूं. So ultimately what I will be getting is that what is the value of this m? M will be equal to 50 kilonewton into x, because what will be this m at this section m? At this particular section, what will the value of the bending moment? 50 into this thing, right? Okay, so that will be equal to what? So 50 into 10 raised to power 3 in Newton and into x. That is the maximum bending moment at this particular section, right? Okay, and multiplied by what? Multiplied by y. Now y will be what? यहां पे देख लेते हैं y का क्या है हमारे पास. So y क्या होगा मेरे पास? The distance from the topmost fiber. So topmost fiber कितना हो जाएगा मेरे पास? ये आपके पास हो जाएगा 7.5. Sorry, this will be 7.5x. Sorry, this will be 7.5x. Not. This will be 7.5x. 75 plus 7.5x. This will be 75 plus 7.5x. And this will also be equal to 75 plus 7.5 plus 7.5x. ये भी 75 plus 7.5x है और ये भी आपका 75 plus 7.5x, राइट. ओके, सो क्या हो जाएगा आपका ये आपका हो जाएगा 75 plus 7.5x, okay, and divided by what? Divided by 2 and divided by I. Now what is this I? That is your BD cube by 12. Ultimately that is your 75 plus 7.5 into x divided by, that is your B, and d cube and into and plus 1, it will be 4 ultimately, because that is b and d are equal, right? Ultimately it will be equal to 4 and divided by 12. So if you further solve it, ultimately you will be ultimately getting, dear students, if you further solve it, I am directly writing the answer. उसके बाद क्या करना है आपको? मैक्सिमम मिनिमम वाला कॉन्सेप्ट लगाना है. सो मैक्सिमम मिनिमम वाला कॉन्सेप्ट कैसे लगेगा? दैट इज योर d सिग्मा डिवाइड बाई dx इज इक्वल टू 0. तो यहां से आपको x की वैल्यू मिल जाएगी. अल्टीमेटली आपको x की वैल्यू क्या मिलेगी यहां से? Ultimately you will be getting the value of x is equals to 5 meters. Ultimately I am directly writing the answer. The value of x ultimately come out to be equal to 5 meters. So Khagsar has got 5 meters, Sameer has got 10 meters, Dev Singh has got 5 meters. The correct answer of this question will be what? It will be 5 meters only, dear students. So 5 meter जो होगा इसका सही आंसर हो जाएगा. So 5 मीटर का जो है आपका सही आंसर हो जाएगा. ध्यान रखना, मैंने इसको पूरा सॉल्व नहीं किया. अल्टीमेटली जब आप इसको सॉल्व करोगे and then you will do d sigma divided by dx is equal to 0, ultimately you will be getting this as the correct answer of this particular question, dear students. Okay, so this was the this question. Now let us move to next question. This question, इसका मुझे आंसर बताइए, इसका आंसर क्या होगा? The cross section of a cantilever beam is shown below. Okay, it is subjected to an end couple of 40 kilonewton meter hogging. The ratio of the maximum tensile stress to the maximum compressive stress is what? That is what you have to find. The maximum tensile stress and the maximum compressive stress, it is subject to hogging moment, and it is a cantilever cross section. That is also important. It is a cantilever beam. Something is given here, that is cantilever beam. Waiting for the answers, dear students. Like, share and subscribe also, dear students. बताइए बताइए इसका आंसर क्या होगा? आई एम वेटिंग फॉर द आंसर्स, वेटिंग फॉर द आंसर्स. मैं आपके आंसर का वेट करो, बताने को मैं आपको आंसर बता दूंगा, लेकिन फिर मजा नहीं आएगा. इट विल नॉट बी a good thing, right? So I want your answers, then obviously I will be explaining you the question also. देव सिंह रावत इज सेइंग 0.5. ओके, देव सिंह रावत आप 0.5 बता रहे हो. देखो थोड़ा ध्यान देना, हॉगिंग मोमेंट है, हॉगिंग. तो अगर हॉगिंग मोमेंट होगा, थोड़ा ध्यान रखना, अगर हॉगिंग मोमेंट होगा, मैं एग्जांपल लेता हूं, दिस एग्जांपल, दिस कवर. अगर हॉगिंग मोमेंट होगा डियर स्टूडेंट्स, इफ देयर इज अ हॉगिंग मोमेंट लाइक दिस, वी हैव कंप्रेशन एट द टॉप एंड टेंशन एट द बॉटम. We have two types of moments. One is called as the sagging moment, one is called as the hogging moment. ध्यान रखना इस चीज का, ठीक है ना. तो जो आपका sagging moment होगा, sagging moment में compression at the top and tension at the bottom, and in case of hogging moment we have different else, right? Now let me again make you explain what do I mean. एक बार मैं डायग्राम के थ्रू आपको बताता हूँ, एक्सप्लेन करता हूँ. फॉर एग्जाम्पल, ये आपके पास एक मोमेंट है, आपके पास दिस इज अ बीम विद यू. ओके, इस बीम में अगर आप एक ऐसे लोड लगाओगे, ये वाला, और ये आप ऐसा लोड लगाओगे, अल्टीमेटली you will be getting this structure. So here we have tension at the bottom and compression at the top. If you have, and this structure is called as a sagging structure because ये आपका sag में convert हो गया, right? If you have this type of moment acting, ये क्या होगा आपका? Like this. Just wait a second. Yeah. So here at the top we will have tension, at the bottom we will have compression. Okay, I'm not feeling well from past 2-3 days, so that is why I'm coughing a lot. So T and C. Now the question is, the cross section of a it is subjected to an end couple of 40 kilonewton meter. Okay, the ratio of the maximum tensile stress to the maximum compressive stress will be what? That is what we have to find. Just apply directly the bending stress formula, that is your sigma by y m by I is equal to E by R. The geometric property is not needed, so I will not be using this property. I will be only using this property, that is sigma by y is equals to m by I only. Okay, now it is a hogging moment is acting, so moment is constant, moment we do not have. So if you take the ratio, the moment will get cancelled out ultimately if you are going to take the ratio. Okay, and the value of I will also be same, because moment of inertia about the neutral axis is not going to change ultimately. Only this y is going to change ultimately, right? Only the value of this y will going to change ultimately. So I will say that sigma c, right, sigma compression divided by sigma tension, or sigma, let me write like this, because at the hogging moment we have the tension at the top. So sigma, and in the question it is asking me what? It is asking me the ratio of maximum tension stress to compressive stress. So sigma T divided by sigma C will be equal to what? It will be equal to, so tension will be at this position, right? So tension will be what? So tension will be here at the top, we will have tension, at the bottom we will have the compression. So what is the distance of the top? That is your 2. So 2 is the distance from the top, that is your 2. 100 divided by the bottom. Bottom is what? The bottom is 100 divided by 100. So ultimately the answer will come out to be what? It will come out to be 2. So sigma T divided by sigma C will be equal to 2. What is the correct answer of this question? The correct answer will be A, will be the correct answer of this question, dear students. और आपका आंसर क्या आ रहा था यहाँ पे? आप लोग का आंसर आ रहा था, what was your answer? Your answer was 1/2. No, it is not 1/2, dear students. It is 2. 2 आपका आंसर करेक्ट आएगा यहाँ पे, ठीक है ना? तो आपने थोड़ा सा कैलकुलेशन में शायद मिस्टेक करी है. You have done a little bit of calculation mistake might be. So आपका जो करेक्ट आंसर है वो 2 होगा, ना कि -2. Just wait a second. Let me also take some medicine. Okay, just wait a second. Now fine. Okay, yes. So very good, dear students. So what is the correct answer of this question? So A will be the correct answer. Samir has got the correct answer. Very good, Samir. Thumbs up to you. देव सिंह रावत, यस, बहुत बढ़िया, बहुत बढ़िया देव सिंह रावत, बहुत बढ़िया. आपका 2 एकदम करेक्ट आंसर है, बहुत बढ़िया. विजय धीमान, सही से पढ़ाए सर. यस, हाँ एकदम सही चल रहा है, कोई दिक्कत नहीं है. आप ना बस क्वेश्चन को सॉल्व करते रहिए. क्वेश्चन को सॉल्व करेंगे तो प्रॉब्लम नहीं होगी आपको, ठीक है ना? तो आप क्वेश्चन को जो है सॉल्व करते रहिए, आप लोगों को प्रॉब्लम नहीं होने वाली है. यू जस्ट कीप ऑन सॉल्विंग द क्वेश्चन, यू विल नॉट फेस एनी इशू. ओके, सो लाइक, शेयर एंड सब्सक्राइब ऑल्सो स्टूडेंट्स. आप लाइक करो, शेयर करो, सब्सक्राइब करो. यू ऑल्सो शेयर विद योर फ्रेंड्स ऑल्सो, डियर स्टूडेंट्स. सही से पढ़ाओ. ओके, गेटिंग माई वॉइस? ओके, सो आई वॉज सेइंग दैट ये रिविजन सेशन है विजय. सो रिविजन सेशन में क्या होगा अल्टीमेटली, मैं मान के चल रहा हूं, आई एम प्री एज्यूमिंग कि आपको थोड़ा थोड़ा कॉन्सेप्ट आता है. सो रिवीजन सेशन में हम लोग सिर्फ और सिर्फ क्वेश्चंस सॉल्व कर रहे हैं. वी आर जस्ट सॉल्विंग क्वेश्चंस एंड क्वेश्चंस ओनली. सो अगर आपको बिल्कुल भी कॉन्सेप्ट नहीं है स्ट्रेंथ ऑफ मटेरियल का, देन ऑब्वियसली यू विल फेस सम इशू विद दीज क्वेश्चंस. ओके, सो आवर अल्टीमेट मोटिव इज टू, you can say, solve questions, and then with the help of questions we have to understand the answers or to understand the concept. That is our ultimate motive is. Okay, so that is what we are doing, Vijay. So पहले हम लोग क्वेश्चन सॉल्व कर रहे हैं. अगर आपको बिल्कुल भी कॉन्सेप्ट नहीं होगा तो फिर प्रॉब्लम होगी समझने में. अगर आपको कॉन्सेप्ट थोड़ा बहुत पहले से आता है तो आपको प्रॉब्लम नहीं होने वाली है. यू आर नॉट गोइंग टू फेस एनी इशू इन दिस. ओके, यू लाइक, शेयर एंड सब्सक्राइब ऑल्सो डियर स्टूडेंट्स विद योर फ्रेंड्स ऑल्सो, उनको भी थोड़ा पता चले. चलिए आगे बढ़ते हैं. नेक्स्ट क्वेश्चन. This question, dear students, try to solve this question. A beam of triangular cross section as shown below is subjected to a shear force of what? 15 kilonewton. The shear stress at a point located 50 mm from the top of the beam is what? कि जो top of the beam से अगर आपको 50 mm पे अगर आपको shear stress निकालने होंगे, what you have to do ultimately? So just have to apply the normal formula. Shear stress का formula क्या होता है हमारे पास? The shear stress is given by VA into Y bar divided by I about the neutral axis and multiplied by B. आप ये वाला कॉन्सेप्ट लगाओ तो आपको इजीली आपको इसका आंसर मिल जाएगा. यू विल नॉट फेस एनी इशू इन गेटिंग द आंसर. आई वांट द आंसर फ्रॉम एवरीवन फॉर दिस पर्टिकुलर क्वेश्चन. आई वांट आंसर फ्रॉम एवरीवन. सो अगर आप ऊपर से देखोगे, ऊपर से कहां पे? 50 mm, ऊपर से 50 mm पे. तो ऊपर से 50 mm मतलब जो एरिया बनेगा वो एक तरह से ट्रेपेजोइडली बनेगा आपका. देयर विल बी ट्रेपेजोइडली, राइट? सो ऊपर से अगर आप एक 50 mm थोड़ा नीचे आओगे यहां पे, it will be 50 mm of distance, so the area which you will be getting, it will be trapezoidal, right? अब आपको ट्रेपेजोइड का कैसे करते हैं वो आपको निकालना है बस. अब आपको तो आपका आंसर इजीली आ जाएगा. सिमिलर ट्रायंगल की प्रॉपर्टी से निकालना है कि कैसे निकालना है, इट ऑल डिपेंड्स ऑन यू, हाउ डू यू वांट टू सॉल्व दिस पर्टिकुलर क्वेश्चन. तो आपका फिर आंसर आ जाएगा, ठीक है. क्वेश्चन सही से नहीं दिख रहा है, मैं आपको विजय बता रहा हूं कि क्वेश्चन क्या है। तो क्वेश्चन क्या है आपका विजय, अ बीम ऑफ ट्राइंगुलर क्रॉस सेक्शन, देखो मैं आपके बना भी देता हूं साइड में, ठीक है ना, मैं एक बार बना देता हूं। ये जो लिखा हुआ है तो आपको दिख रहा होगा क्या लिखा हुआ है ये, ठीक है ना, ये तो जो लिखा है वो तो दिख रहा होगा आपको, लेकिन ये बना क्या है ये मैं साइड में बना देता हूं। यहाँ पे ये एक ऐसे ट्राइंगुलर बीम बनी हुई है ऐसे उल्टे वाली, दिस इज योर ट्राइंगुलर बीम, ऐसी आपकी ट्राइंगुलर बीम बनी है यहाँ पे। ये जो डिस्टेंस है आपका, दिस इज योर 150 mm, दिस इज योर 150 mm डिस्टेंस। हाउ मच इज दिस डिस्टेंस, दिस डिस्टेंस ये दिया नहीं है आपको, लेकिन ये वाला डिस्टेंस आपको दिया हुआ है, दैट इज योर 180 mm इज दिस डिस्टेंस। तो क्वेश्चन में आपको बोलता है कि ऊपर से लेकर के, जब आप ऊपर से मतलब जब बेस से यहां पे चलोगे नीचे की तरफ 50 mm, तो आपका shear स्ट्रेस कितना होगा। द shear स्ट्रेस at a point located at 50 mm from the top of the beam is what? So you have to find the shear stress at this point or at this section. You have to find the shear stress. क्या करोगे, ये वाला फॉर्मूला लगा देना, एरिया चेंज हो जाएगा, y बार चेंज हो जाएगा और आपका b चेंज हो जाएगा, आपका आंसर आ जाएगा। नाउ हु विल गिव मी द आंसर ऑफ दिस क्वेश्चन। ये बहुत ही सोचने वाले क्वेश्चन है स्टूडेंट्स, ये बहुत ही इजी क्वेश्चन नहीं है जो आप सोच रहे हो कि मैं कर दूंगा बस क्वेश्चन को, ये तो हो जाएगा 2 मिनट में, ऐसा नहीं होगा। इसमें आपको क्वेश्चंस में बहुत ज्यादा सोचना पड़ेगा, आपकी जो थिंकिंग पावर है, बिकॉज ये गेट के क्वेश्चंस हैं जो मेरे को लगता है कि ऐसे आ सकते हैं गेट में क्वेश्चंस, तो ये उसके हिसाब से मैंने डिजाइन किए हैं स्टूडेंट्स। तो आपको थोड़ा सोचना पड़ेगा इसमें, यू हैव टू apply the basic concepts and you have to apply the mathematical skills, then only you will be able to solve these questions. ये questions easily आपके solve नहीं होंगे, ठीक है ना। try to solve it, try to solve it. आया किसी का आंसर, आया किसी का आंसर। चलिए पहले इस क्वेश्चन को सॉल्व कर लेते हैं, फिर हम लोग आगे बढ़ते हैं, ठीक है। इस क्वेश्चन को पहले हम सॉल्व करते हैं। मैं आपको एक और हिंट दे देता हूं, लेट मी गिव यू वन मोर हिंट। नाउ व्हाट इज द न्यूट्रल, जो न्यूट्रल एक्सिस होता है ट्राइंगल का, उस पे आपका मोमेंट ऑफ इनर्शिया कितना होता है न्यूट्रल एक्सिस पे, BH नोज इट, एवरीबॉडी नोज इट, दैट इज योर BH क्यूब डिवाइड बाय 36। जो ट्राइंगल का न्यूट्रल एक्सिस होता है उस पे जो आपका मोमेंट ऑफ इनर्शिया निकलता है, दैट इज योर BH क्यूब डिवाइडेड बाय 36 इज द मोमेंट ऑफ इनर्शिया। तो पहले हम क्या यही निकाल लें, चलो पहले यही निकाल लेते हैं। सो बेस क्या है मेरे पास, बेस है मेरे पास 150, राइट। सो 150 इज द बेस, सो 150, व्हाट इज दिस h नाउ, नो दिस h इज 180, ओके, h is 180 whole cube divide by 36. Ultimately, if you solve it, you will be getting 24.6 into 10 raised to the power 6 mm4, mm raised to the power whole 4. This is what ultimately the moment of inertia about the neutral axis will be coming out. So ये आपका moment of inertia निकल गया न्यूट्रल एक्सेस के अबाउट। अब क्या करोगे, अब आप जो है AY निकाल लीजिए, अब आप उसमें AY, बिकॉज जब मेरे को एक एक करके सारी चीजें पता होंगी, अब मैं AY निकाल लेता हूं, ये वाला AY बार, ये निकाल लेते हैं इसको। चलिए विल बी इक्वल टू व्हाट, एरिया विल बी इक्वल टू हाफ इंटू B इंटू 130, राइट, हाफ इंटू B इंटू 130। या एक काम कीजिए, आप निकालिए, पहले मैं आपका वेट करता हूं, मैं आपके आंसर का वेट कर रहा हूं, उसके बाद मैं निकालूंगा उसको। मैं आपके आंसर का वेट कर लेता हूं एक बार, जरा पहले आप निकालिए इसको, फिर मैं निकालूंगा इसको, पहले आप निकालिए। एनीवन जिसका आंसर आया हो, एनीवन। चलिए मैं आपको बता देता हूं उसको। देखिए तो ये आपका क्या हो गया, अगर आप सिमिलर ट्राइंगल की प्रॉपर्टीज लगाओगे तो क्या आपको इसका एरिया मिल जाएगा। जी हाँ, आपको इसका एरिया मिल जाएगा। क्यों नहीं मिल जाएगा आपको इसका एरिया, या तो आप इसको दो ट्राइंगल में इसको डिवाइड कर सकते हो, यू कैन डिवाइड इट इनटू 2 ट्राइंगल्स और एक रेक्टेंगल, तब आप उसका मोमेंट ऑफ इनर्शिया निकाल लो। बिकॉज व्हाट इज दिस AY बार, AY bar is the moment of, you can say moment of area about CG. Moment of area about CG. Where is the CG? Here, somewhere here we will have the CG at a distance of 180 divided by 3. That is your 60 mm from here. To be more precise, 60 mm from here and 120 mm from here. And 120 mm from here you will have the CG somewhere here. तो यहां से आप उसका मोमेंट ऑफ इनर्शिया निकाल रहे हो CG के अबाउट, राइट? मोमेंट ऑफ एरिया ही आप निकाल रहे हो. तो कैसे निकलेगा? या तो अगर आपको ट्राइंगल के फॉर्मूले याद है तो बहुत अच्छी बात है. सॉरी, अगर ट्रैपेजोइडल के अगर आपको फॉर्मूले याद है बहुत अच्छी बात है. ट्रैपेजोइडल के फॉर्मूले याद नहीं है तो पहले आपको ट्राइंगल का निकाल के फिर आपको CG लेना पड़ेगा. ठीक है, तो AY बार कितना हो जाएगा? मैं इसको हटा देता हूं. यहां पे AY बार will be equal to half into base. Now what is this base now? Now what is this base? Now what is this base? This thing can be calculated very easily with similarity of triangles, right? With the help of similarity of, this is your B, okay, this is your this, and something like this. Okay, now here with the similarity of triangles I can say that what is the total height? The total height is 180. What is the base height? The base width is 150. So total upon base is equal to this distance. Now what is this distance? How much is this? So from here it is 50 and from here it will be equal to what? It will be equal to 130. So 130 divided by B. So from here you will get the value of this B. अब B कितना आ जाएगा मेरे पास? 0 से 0 कैंसिल हो गया. ठीक है, ओके. सो B कितना आ जाएगा? 130 into 15 डिवाइड into 15 and divide by 18. ये मोटा मोटा आपका आ जाएगा कितना? 108.33. B will come out to be 108.33. ये आपका आ गया B in mm to here. Okay, and what is this distance? So this distance will be at a distance of 60. So 60 minus 50 divided by 3. 50 divided by 3 comes out to be nearly 43.33. Comes out to be nearly 43.33 and multiplied by 2. Why 2? Because we have two triangles. One is this and one is this. दो triangle है मेरे पास, तो multiply by 2 करना पड़ेगा मेरे को. ठीक है, so plus जो बीच में रेक्टेंगल बचा मेरे पास, रेक्टेंगल का कितना हो जाएगा? B 108.33 into 50. 108.33 into 50 and multiplied by what? जो सेंटर होगा इसका सेंटर कहां से लेकर कहां तक? यहां तक. तो ये 60 हो गया, ये 25 हो गया. So 60 minus 25, 60 minus 25 is 35 and that will be equal to 35. So this is the total AY bar coming out to be. अगर आप इसको कैलकुलेट करोगे, मैं एक बार कैलकुलेट कर लेता हूं इसको कैलकुलेटर में, तो मेरे पास जो टोटल AY बार आ रहा है यहां पे, so 20.83 divided by 2 and 2 will get cancel out. I can directly write multiplied by 43.33 और ये plus 108.33 into 50 into 35. ये आपका नियरली आ रहा है मेरे पास 23471 के आसपास. 23471 के आसपास मेरा आंसर आ रहा है इसका, राइट? दैट इज कमिंग आउट टू बी 23471.5 के आसपास. 0.5 के आसपास मेरा एग्जैक्ट आंसर आ रहा है. अब मैं इसको फॉर्मूले में पुट कर देता हूं. अगर मैं इसको फॉर्मूले में पुट करूंगा अब तो कुछ बचा ही नहीं इसमें. ठीक है ना, तो क्या आ जाएगा मेरे पास? टाउ विल कम आउट टू बी व्हाट? Tau will come out to be V. Now what is this V? Shear force is 15 kilonewton. That is your 15 into 10 raised to the power 3 into AY bar. AY bar is 23471.5. 23471.5 and divided by I into B. Now what is this I? 24.6 into 10 raised to the power 6. 24.6 into 10 raised to the power 6 and multiplied by B. Now what is this B now? So B is equal to 108.33. 108.33. If you calculate it, ultimately it will come out to be 15 into 23471.5 divided by 24.6 divided by 108.33 0.33. Ultimately, it comes out to be 1.34, nearly 1.34, nearly 1.34 megapascals. So, dear student, this is what I am getting. That is your 1.34 megapascals. This is what my question answer is coming. Now, what about you, students? 1.337. Yes, very good, very good. बहुत बढ़िया, बहुत बढ़िया. Everybody, everybody, yes, बहुत बढ़िया. समीर, yes, very good, yes, very good. So 1.34 के आसपास जो है करेक्ट आंसर आ रहा है. बहुत बढ़िया, बहुत बढ़िया. So 1.34 के आसपास जो है करेक्ट आंसर आ रहा है. So किसका आंसर आया, किसका आंसर आया? एक बार चेक कर लेते हैं आंसर क्या है आपका. तो क्या आंसर आ गया इसका? 1.34 के आसपास, राइट? सो द करेक्ट आंसर ऑफ दिस क्वेश्चन विल बी 1.34 मेगापास्कल्स. बहुत बढ़िया. चलिए 1.337, हाँ वो भी सही है. 1.43. विजय, थोड़ा सा आपका ज्यादा आ गया, थोड़ा कुछ कैलकुलेशन में गड़बड़ हुई है आपकी, तो आप एक बार दोबारा चेक कीजिए कैलकुलेशन में कहां पे गड़बड़ हुई है, क्या हुआ है कैलकुलेशन. आप एक बार दोबारा आप अपनी चेक कीजिए, ठीक है. चलिए आगे बढ़ते हैं. नेक्स्ट क्वेश्चन, नेक्स्ट क्वेश्चन, अगले क्वेश्चन की तरफ चलते हैं. आई होप ये आपको समझ में आ चुका है. आई होप यू पीपल आर गेटिंग इट. ये क्वेश्चन है इतने जो ये बहुत ही अच्छे लेवल है डियर स्टूडेंट्स क्वेश्चन का, और लाइव में मैं कोई कराता नहीं, मैं आपको बता रहा हूं, ठीक है ना. ऑलरेडी बहुत ही ऐसे क्वेश्चंस होते हैं लाइव में जो ऑलरेडी आपने पहले कभी किए होते हैं, ठीक है ना. और इसमें बहुत सारे क्वेश्चंस ऐसे मिलेंगे जो आपको भी फर्स्ट टाइम आप कर रहे हो इसको, ठीक है. चलिए आगे बढ़ते हैं. नेक्स्ट क्वेश्चन. चलिए इस क्वेश्चन को कीजिए आप. An unspecified pure bending moment is used to bend an aluminium rod of radius 2.5 mm elastically. Okay, ठीक है. It bent into a circular ring of radius 2 meter. If the same bending moment is used to bend elastically a copper rod of radius 2 mm, the radius of resulting ring is what? So, modulus of elasticity of aluminium is also given and the modulus of elasticity of copper is also given. A, B or C or D. So what do we have to find? Okay, we have to find the radius of the resulting circular ring of copper. चलिए बताइए मेरे को इसका आंसर क्या होगा. थोड़ा सा आप अपना लगाओगे दिमाग तो आपका आंसर इसमें आ जाएगा. You will get the answer. Only one link is given. The link is that, what is the link? The link is that if the same bending moment is used, this is a link dear students, and with the help of this link you will get the answer of this question. If the same bending moment is used, that is a link. ये आपको एक लिंक दिया हुआ है. बताइए, मैं इसका आंसर का वेट कर रहा हूं आपके लिए. तो एक लिंक अपने को मिल चुका है. नाउ व्हाट इज द लिंक? द सेम बेंडिंग मोमेंट इज देयर. वेटिंग फॉर द आंसर्स, वेटिंग फॉर द आंसर्स. और इजी क्वेश्चन है, कुछ ज्यादा डिफिकल्ट क्वेश्चन नहीं है वाला. ये इजी क्वेश्चन है, ये इजी क्वेश्चन ही कैटेगरी में आता है. 1.404. ओके, समीर इज सेइंग 1.404, ऑप्शन नंबर 2. चलिए ठीक है, आगे बढ़ते हैं हम लोग, इसमें कुछ सॉल्व करने का ट्राई करते हैं. 1.404 इज द आंसर विच समीर इज गेटिंग. ओके, ओके, समीर इज सेइंग ऑप्शन 2. ओके, गुड. नाउ लेट अस ट्राई टू सॉल्व इट. एक दो का आंसर और आने दो, फिर हम लोग इसको स्टार्ट करेंगे सॉल्व करना. एक दो का आंसर और आने दो इसमें. Let one or two more students give me the answer of this question, then we will solve this question also. Dear students, like, share and subscribe also, ताकि बाकी स्टूडेंट्स की थोड़ी हेल्प हो जाए, राइट, जो गेट की लास्ट मोमेंट पे प्रिपरेशन करना चाहते हैं. चलिए, बाकी किसी का रिप्लाई नहीं आया मेरे पास, बट लेट मी ट्राई टू. Now what is the link given? The link is that we have the same bending moment. Now if we same bending moment, let us apply the bending stress formula. That is your sigma by y is equal to m by I is equal to E by R. Now in this question, let us try to understand which formula I have to use and which formula I have to neglect. An unspecified pure bending moment is used to this. Now see here, some geometrical properties are given. Radius is given, okay, elasticity is bent, so some geometrical properties are given. If geometrical properties are given and the concept of moment is also given, I will be using this these two results. I will not be using the first stress divided by the location of the maximum or the location of the fiber from the neutral axis. I will not be using this thing. Now I will be using only this thing. Now here, that is your m by I is equal to E by R. To be more precise, this can also be written as m is equal to E into I divided by R. And the bending moment is same bending moment. It means that E into I divided by R of material number 1, that is, say it is of aluminium, it should be equal to E into I divided by R of what? Of copper, Cu, copper, right? Okay, now अब मैं values put कर देता हूँ, आंसर आ जाएगा, तो कुछ बचा ही नहीं है इसमें, ठीक है ना? So it will be equal to what? It will be equal to what? It will be equal to E into I. Now what is the E of aluminium? 70 gigapascals. So 70 gigapascals into I. What is the polar moment? What is the moment of inertia of a circular ring or a circular rod? Pi by 64 into d raised to the power 4. That is your pi by 64 into d raised to the power whole 4 divided by R of aluminium. Now what is the R of aluminium? Bent into a rod of radius 2.5 mm. So divided by 2.5 mm. There is no need to convert the units because some units will get cancelled from the right hand side. There is no need to convert the units also. It will be equal to 120. 120 again multiplied by pi divided by 64 into d copper raised to the power 4. This is your d aluminium raised to the power 4 divided by, now I have to find the radius, right? I have to find the radius of 2 mm. So this is also given as 2 mm. This is my 2 mm. Now what do I have to find? I have to find what? I have to find it is bent into a circular ring, or if the same ring, the radius of the resulting ring, okay? The radius, okay? And an unspecified pure bending moment is used to bend an aluminium rod of radius 2.5. Okay, that is the radius of the ring given, okay? So that is your 2 mm that is given here, right? That is your 2 mm given here. So the little mistake here, little mistake is here. There is a little mistake here. So that is your 64 into R that I have to find, and here it was what? It was equal to, so this was equal to, if radius was 2.5 meter, diameter will be equal to 5. So diameter is equal to 5 here. The diameter is equal to 5 here, 5 raised to the power whole 4 divided by 64, and it will be equal to what? 2 mm is the ring. Now this is the final solution. So pi by 64 gets cancelled out from here and here, okay? And this is what? The diameter of the copper ring is what? The diameter of the copper ring is, a radius is 2 mm, so diameter will be 4 mm. So here the diameter is 4 mm. Let me also write down the diameter of this also, that is your 4 mm. So 4 mm is the diameter, 4 is to power 4, okay? Now that will be the ultimate. So R will be equal to what? R will be equal to, if you solve it, let me try to solve it, R. So R will be equal to 120 into 4 raised to the power 4 divided by 70 and divided by 5 raised to the power 4 and multiplied by 2. It ultimately comes out to be 1.41, nearly 1.41, nearly 1, not even 1.41, 1.40, nearly 1.404 meters, nearly 1.404 meters. That is what it is coming out to be, 1.404. Yes, Dev Singh, 1.404 is the correct answer which we are getting, okay? 1.404. So what is the correct answer? 1.404. What is the correct option? 1 point, so 2 is the correct answer of this question. Very good. Everyone, very good, very good. Like, share and subscribe also, dear students. Let us move to the next question. This question. Try to solve it. ये भी बहुत easy question है. Shear stress at point C for the given T beam. So it is a T beam. If somebody is not able to see it, let me एक थोड़ा बड़ा बना देता हूं मैं. This is a T beam given. Okay. This is your 100 mm. This is what is 100 mm given. This is given as 15 mm. ये आपका 15 mm दिया हुआ है. This is your 15 mm here. Okay. This is your 25 mm. This given is your 25 mm. And this given is your 75 mm. From here to here we have the 75 mm. So what do we have to find is that we have to find the shear stress at point C. Which point? This point, at this point C. और आपको पता है कि जब हम इसका shear stress डायग्राम बनाते भी हैं तो यहां पे shear stress ऐसे आता है और ये एकदम से आपका इंक्रीज होकर फिर आपका ऐसे जाता है. That is what the shear stress diagram is all about of this particular point. Now we have to find the shear stress at the point C. We have to find the shear stress. Try to find it out. Waiting for the answers. Waiting for the answers. Like, share and subscribe also, dear students. बाकी लोगों के साथ आप like, share and subscribe भी कीजिए इसको. चलिए चलिए चलिए, क्या होगा इसका आंसर? बताइए मेरे को, बताइए बताइए क्या इसका आंसर होगा. Waiting for the answers. Waiting for the answers. अब देखो एक चीज देखो, अब उस पॉइंट पे जहां पे वो सी पॉइंट की बात कर रहा है, द पॉइंट विच इट इज टॉकिंग अबाउट, आई एम गिविंग यू अ हिंट नाउ, राइट? So this point C which it is talking about, it will have two stresses. One will be this and one will be this. If somebody is asking you what will be the stress at this point, always report the maximum stress. Because whenever we are designing a particular section, जब भी हम किसी को डिजाइन करते हैं सेक्शन को, हम हमेशा मैक्सिमम स्ट्रेस के लिए डिजाइन करते हैं उसको, ना कि कम स्ट्रेस के लिए. तो जब भी देखो इस क्वेश्चन में ऐसे बोला नहीं है कि आपको मिनिमम चाहिए मैक्सिमम चाहिए, लेकिन अगर आपको पॉइंट सी पे स्ट्रेस निकालना जंक्शन पे, तो कौन सा आप निकालोगे? आप हमेशा मैक्सिमम स्ट्रेस ही निकालोगे. ध्यान रखना इस बात का. सो आई हैव गिवन यू अ हिंट दैट यू हैव टू कैलकुलेट द मैक्सिमम स्ट्रेस. दैट इज ऑल. सो रेस्ट यू कैन डू. ओके, नाउ ट्राई टू सॉल्व इट. वेटिंग फॉर द आंसर्स. रेस्ट यू कैन डू, आई गेस. फर्स्ट ऑफ ऑल यू हैव टू कैलकुलेट द सेंट्रोइड ऑफ द होल सेक्शन. पहले आपको टी बीम का सेंट्रोइड निकालना पड़ेगा, उसके बाद ही आपका आंसर आएगा. समीर इज सेइंग 58.823. ओके, now let us try to solve it. Let us try to solve it. First of all, let us write down the formula. The shear stress at any section is given by V into A into Y bar divided by I about the neutral axis into B. Do we know B? Yes, we know B. Now how much will be this B? B will be 25 mm. B at this point C, at this point C, B will be equal to 25 mm of the web which I will be taking. Okay. Now, do I know INA? I don't know the value of INA. I do not know that what will be the moment of inertia of this T section. So first of all, I have to calculate this moment of inertia, and then I will put it in the formula. I will get the answer, right? Okay. Now to calculate the moment of inertia, the knowledge of centroid is important. First of all, let us calculate the centroid from this axis. Let me take, this is some axis. Now from here, let me calculate the centroid. Let us say it is y bar some distance. So centroid y bar will come out to be equal to what? 25 A into y bar will be equal to 25 into 75 minus 15 with 60, 25 into 60 into 30, 25 into 60 into 30 plus 100 plus, this is 100 into 15, 100 into 15, this will be 7.5, 7.5 and plus 30, plus 60 will be equal to 67.5. So yes, it will be equal to 67.5. So 100 into 15 into 67.5 plus 100 into 15 into 67.5 divided by the total area. Now what is the total area? Total area is 65 into 30, from here 65 into 30 and plus 100 into 15. 100 into 15, not 30 into 60, sorry, into 60, this one, 60. So ultimately what your y bar will come out? Your y bar will come out to be nearly 65 into this, okay, this will 0 will get cancelled out, and your y bar will come out to be nearly, it is coming out to be nearly 48.75. Y bar is coming out to be 48.75 mm from the bottom. That is your y bar, which is coming out to be 48.75. Let me also mark the y bar in this figure. So y bar is coming out to be what? It is coming out to be 48.75. 48.75 mm. ये y bar की वैल्यू आ चुकी है 48.75. अब जब y bar मेरे पास आ गया तो क्या मैं मोमेंट ऑफ इनर्शिया निकाल सकता हूं? बड़े आसानी से, अब तो कुछ बचा ही नहीं इसमें. तो मोमेंट ऑफ इनर्शिया कैसे निकलेगा आपका? The moment of inertia about the neutral axis will be equal to let me take the bottom parallel axis theorem लगा दूंगा मैं वहां पे, ठीक है ना. So let me take the bottom, that will be equal to 25 into 60 cube divided by 12. That will be equal to 25 into 60 whole cube divided by 12. Okay. Sorry. Plus plus AH square 25 into 60 multiplied by 48.75 minus 30 whole square. Because if you see this 48.75 minus 30, because this is 60, from here to here we have this 60 का half कितना हो जाएगा 30. So 48.75 minus 30 square. So obviously it will be 18.75 something square, right? Okay. So this and plus for the upper rectangle now, upper flange, this upper flange. अब इसके बारे में बात करते हैं, upper flange के बारे में, इस flange के बारे में. Area is what? Area is 100 into 150 is area, and what will be BD cube by 12? 100 into 15 cube divided by 12. 100 into 15 whole cube divided by 12 plus area is what? 100 into 15 into the difference between the centroid of the two areas. So what it will be? It will be equal to, again 18.75, it will be 18.75 whole square. Okay. Why 18.75? आप कैलकुलेट खुद भी करोगे तो आपका आंसर आ जाएगा 18.75 whole square. ये 48.75 है. 48.75 में से अगर आप 75 को माइनस करोगे, 48.75 में से अगर आप 75 में से अगर आप 48.75 को माइनस करोगे, it will ultimately come out to be 26.25. So 26.25 and minus 7.5. minus 7.5 will be equal to 18.75, right? So ultimately it will be 18.75. तो ये मेरा total moment of inertia आ जाएगा. इसको जरा एक बार calculate कर लेते हैं. Ultimately what it will come out to be. So 25 into 60 whole cube divide by 12 and plus 25 into 60 into 18.75 square and plus 100 into 115 cube divided by 12 and plus 100 into 15 into 18.75. Dear students, it is coming out to be nearly 1532812. 1532812.5 mm raised to the power 4. This is the value of INA which is coming. That is the moment of inertia about the neutral axis is coming out to be this much. ये आ चुका है, तब तो कुछ बचा ही नहीं है, अब तो बस फॉर्मूले में लगा दो आप, राइट? तो टाउ क्या हो जाएगा आपके पास? आपके पास टाउ आ जाएगा V. Now what is this V now? 25 kilonewton is the value of V. 25 into 10 raised to the power 3 into area ऊपर वाले फ्लैंज का एरिया कितना था? 100 into 15. I still remember it. That is 100 into 15. बता ही चुका 18.75 तो हम निकाल ही चुके थे. 18.75 डिवाइड बाय द मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया इज 1532812. 1532812.5, right? 0.5 is also there and multiplied by B. Now what is this B here? यहाँ पे B कितना है ये वाला? 25 mm is the B at this portion because मेरे को maximum निकालना है ultimately, right? Into 25. If you solve it, dear students, आपका जो आंसर आएगा, if you solve it, so 25 into 15 into 18.75, 0 cancel out into 10 to the power 6 and divide by 153.28 and divide by 25. Dear students, my answer is coming out to be 18.35 Newton per mm square. That is what the shear stress at this section is coming. 18.35 न्यूटन पर mm स्क्वायर. ये आंसर आ गया. समीर 18.348. बहुत बढ़िया, बहुत बढ़िया समीर. इट मींस दैट आपने पहले जो है कैलकुलेशन में कुछ मिस्टेक किया था. इट मींस दैट यू मस्ट हैव डन सम कैलकुलेशन मिस्टेक अर्लियर, राइट? सो नाउ यू आर गेटिंग द करेक्ट आंसर. सो नाउ इट इज फाइन, आई गेस. नाउ इट इज फाइन. यस, वेरी गुड, वेरी गुड, वेरी गुड समीर. रियली हैप्पी विद यू. यस, वेरी गुड. बिकॉज ये क्वेश्चन सॉल्व करना इतना आसान नहीं है स्टूडेंट. जो हम क्वेश्चन सॉल्व कर रहे हैं, दीज क्वेश्चंस रिक्वायर सम technical as well as the calculative ability. Then only you will be able to solve these questions. Otherwise you will not be able to solve. Yes, very good. Like, share and subscribe also, dear students. Like, share and subscribe also. 18.348 and I am getting 18.35, almost similar. I did not find combined value of mi. Oh, that is the mistake which you did. Okay, so do not try to do this mistake. Do not repeat this mistake in the actual gate examination. In actual gate examination, try to find out the exact values. Okay, so let us proceed now further. Let us further proceed. I hope that you all are enjoying. आपको समझ में तो आ रहा है ना आपको, right? आपको समझ में तो आ रहा है ना कि ऐसे ही चल रहा है, पता नहीं क्या चल रहा है, समझ ही नहीं आ रहा है, तो एकदम हवा में चीजें जा रही हैं, ऐसा तो नहीं है ना? आई होप यू पीपल आर एंजॉइंग, राइट? चलिए, ओके. और अगेन, अगर किसी को बिल्कुल भी कॉन्सेप्ट नहीं है स्ट्रेंथ ऑफ मटेरियल का, उसके लिए थोड़ा प्रॉब्लम आएगी डियर स्टूडेंट्स. आई एम अगेन टेलिंग यू, उसके लिए थोड़ा प्रॉब्लम आएगी. तो ये कोर्सेस उन्हीं के रिवीजन चल रहे हैं जिसने एक बार पढ़ चुका है लेकिन थोड़ा सा डाउट्स उसको है, लेकिन अब वो न्यूमेरिकल सॉल्व करेगा तो डाउट्स उसके क्लियर हो जाएंगे. ठीक, उसके लिए है ये सेशन. जिसने बिल्कुल ही नहीं पढ़ा है उसके लिए तो ऑब्वियसली नहीं है सेशन, उसको समझ ही नहीं आएगा क्या चल रहा है यहाँ पे. ठीक है ना? सो the person who has not read anything in strength of material, he or she will not be able to get whatever is going on here. Okay, but if you have read strength of material for one time but you still have some doubts, then all the doubts will be cleared by the end of this session. All the doubts will be cleared. Okay, it will be a revision session for you actually. So now let us proceed now. But before proceeding, let me tell you a very important thing, dear students. You can go for the Testbook Pass. So we have one pass for more than 100% courses. A lot of mock tests are there, as well as we have done a lot of selections also. Okay, expert guidance will be provided to you, as well as good exam strategy will be there. One pass for complete learning. And if you know that I am also taking classes for SSC JE on the Testbook site and the Testbook official channel में मैं जो है SSC JE क्लासेस भी लेता हूँ. मार्च 21 में SSC JE का एग्जाम होगा. सो अभी जो है वहां पे जो अभी सब्जेक्ट चल रहा है दैट इज अ ट्रांसपोर्टेशन इंजीनियरिंग. कल से रेलवे स्टार्ट हो जाएगा. रेलवे इंजीनियरिंग विल बी स्टार्टिंग फ्रॉम टुमारो, राइट? सो दिस इज द Okay, so dear students, if anybody of you wants to understand the concepts in deep, because YT पे तो आपको भी पता है कि जितने भी टीचर्स पढ़ाते हैं बहुत ज़्यादा डीप में हम लोग नहीं जा पाते हैं, ठीक है ना? So if anybody of you wants to understand the concepts in deep, why is it actually happening? So you can also, obviously these are some paid courses, so you can go and buy those courses, as well as you can also enter my referral code also, that is your Varun and K, and you will be getting a discount of around 20% flat. So flat 20% discount will be there on all the courses whatever you are going to buy from the Testbook channel. So आगे बढ़ते हैं हम लोग. Let us proceed now further. The next question, this question. Let us not solve this question. It is an easy question. You can solve it. Let us further proceed. This question also you can solve. Let me read the question first of all. Not solve the question. A cantilever beam has a cross section of isosceles triangle and the isolated beam. Okay. If the moment of inertia is I z, this thing, the maximum bending stress, you can find it. You can find it. No need to worry. Next question. Let me try to see this question. A cylindrical rod is welded as such as figure. Okay. M is equal to this thing, the ratio of the maximum bending stress to maximum shear stress. You can get this. You can get this. Not a difficult question it is. You can get this also. ये भी आपका maximum bending stress ये भी आपको मिल जाएगा. This also you can solve. Okay. Maximum, or this is a very simple concept. This is a very simple concept. Then we have the fillet welds here. Okay, the tensile force, this also you can solve it. Theories of. Now let us come to the next chapter, dear students, right? Otherwise if we solve every question, then it will take a lot of time. We will not be able to finish the syllabus on time. So now, without wasting any time, let us move to the next chapter, that is chapter number 5, theories of failure. So we have 5 theories of failure, and all theories of failure I think that you should be knowing. So let us directly start with the question. This question number 1, it is a bit of theoretical question, but question number 1, who will tell me the answer of this question number 1? Rankine theories for which material? Tresca theories for which material? Von Mises theories for which material? Waiting for the answers. Four. Samir is saying 4. P2. What is this P? P is the Rankine theory. Yes, it is for brittle material, right? That is also called as the maximum principal stress theory. Yes, very good. That is for brittle material. Tresca theory. That is supposed to be as the most conservative theory. Tresca theory. Very good, right? Then R. R is the ductile. Yes, obviously that is for ductile material. So yes, 4 is the correct answer of this question, dear students. So 4 is the correct answer of this particular question. Next question. This question. Which of the following of the material failure under biaxial stresses sigma 1 and sigma 2 and yield stress sigma y with their corresponding graphical representation? So every theory of failure has a different graphical representation. Now the question is how that graphical representation has been derived. So that is a very long concept which I will not be able to, you can say, deliver on this YT, because it will take further 30 minutes or 40 minutes. But again, as I am saying, that this is only for those people who have at least done strength of material for at least one time, and they are doing the revision, right? Okay, that is a revision course basically. So now किसको इसका आंसर पता है? इसका आंसर क्या होगा? What will the answer of this question? कि कौन सी थ्योरी का रिप्रेजेंटेशन क्या है आपका? Maximum normal stress criteria. Okay, who will give me the answer? 3. Okay, PM, that is your P, and this M. Yes, correct. This is correct. This is correct. Let me take a blue marker here. So maximum normal stress criteria. Yes, this is correct. Very good. Then you are saying QN, Q, maximum distortion energy theory. It has an ellipse like this. Yes, that is also correct. Yes, very good. Then we have the maximum shear stress theory. Some rhombus type of things is formed here, right? That is Q, R is L, right? R is L. That is also correct. Yes, C is the correct answer, or 3 is the correct answer of this particular question. Very good, Samir. Very good. Very good. Next question. Try to solve this question. Bars of square and circular cross section of with the 0.5 meter length is made of a material with a shear strength of 20 megapascals. Okay, the square bar cross section dimension is 4 centimeter into 4 centimeter, and the cylindrical bar cross section diameter is 4 centimeter. The specimen are loaded as shown in the figure. So this is the loading, right? Some here we have the longitudinal tension is there, then the compression is there, then we have the twist is also there, as well as the bending load is there. Which specimen will fail due to the applied load as per the maximum shear stress theory? As per the maximum shear stress theory, which material will fail earlier? Now who will give me the answer of this question? Now what is the maximum shear stress theory? That a material, it fails in shear with combination of one or more principal stresses, right? That is what the theory is all about. That the maximum principal stress, the maximum shear stress theory is what? So when you have the principal stresses due to the combination of principal stress, tau max will come out to be sigma 1 minus sigma 2 divided by 2, and then we divide with the factor of safety. It means that we are basically dealing with the principal stresses, right? Now here you find which will generate principal stresses of tension, and direct compression will generate the principal stresses, that is for sure. That is direct compression, direct tension will generate the principal stresses, because no other stress is acting in any other plane. बाकी प्लेन्स पे कोई स्ट्रेस एक्ट ही नहीं कर रहा है, बाकी प्लेन पे कोई स्ट्रेस एक्ट ही नहीं करेगा, तो प्रिंसिपल स्ट्रेस ही बन गए अल्टीमेटली आपके वो, राइट? सो करेक्ट आंसर सर क्या हो जाएगा? द करेक्ट आंसर ऑफ दिस क्वेश्चन विल बी ऑप्शन नंबर 1, दैट इज टेंसाइल एंड कंप्रेसिव लोड स्पेसिमेन. यही तो आपके प्रिंसिपल स्ट्रेस हैं आपके, बिकॉज इस वाले में तो कोई एक्ट ही नहीं कर रहा, इस वाले में तो कुछ एक्ट ही नहीं कर रहा आपका, और ना कोई शेयर स्ट्रेस एक्ट कर रहा है आपका. तो दैट बिकम्स योर अल्टीमेट, इफ यू रिजॉल्व इट, दिस इज योर अल्टीमेट, राइट? दैट अल्टीमेटली बिकम्स योर व्हाट? It becomes your principal stresses. So that is your A will be the correct answer of this question. Next question. A circular bar is subject to an axial force and a shear force. The difference between the two principal stresses is 120 megapascal. Based on the maximum shear stress theory, what is the factor of safety if elastic limit of the bar is 300 megapascals? You have to find the factor of safety. Who will give me the answer of this question? 2.5. That is very simple actually, right? What is the difference between two principal stresses? The difference between two principal stresses, that is your sigma 1 minus sigma 2, it is equal to 120 megapascals. That is your 120 megapascals, right? Okay, and we also know that now if elastic limit of the bar is 300 megapascals, right? So maximum shear stress कितना आ जाएगा आपके पास? Maximum shear stress will be equal to sigma 1 minus sigma 2 divided by 2. Sigma 1 minus sigma 2 divided by 2, that will be equal to 120 divided by 2, that will be equal to 60 megapascals. So 60 megapascal is the maximum shear stress. Let me change marker. 60 megapascals, right? Okay. Now allowable shear stress is what? The allowable shear stress is what? That will be equal to 300 divided by 2, because that is tau max divided by 2, right? That is 300 divided by 2 will be equal to 150. That is the allowable. So what is the factor of safety now? So factor of safety is equal to allowable divided by actually happening. That is your 150 divided by 60. So what is this 150 divided by 60? That is equal to 6 into 2 is 12 and 6 into 5 is 30. That is 2.5. So C will be the correct answer of this question. Yes, very good, Samir. Very good. Yes, option 3. Very good. Very good. Very good. C with the correct answer. Next question. Next question. The yield of steel in both tension and compression is 250 megapascal and Poisson ratio is 0.25. It is subjected to a principal stress of 120 megapascal tensile and 60 megapascal tensile and 30 megapascal compressive. The factor of safety according to the maximum strain energy theory is what? Try to give me the answer of this question. Now, first of all, what is the maximum strain energy theory, right? So you must be knowing that sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 times of mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 1 sigma 3. Okay, it should be always less than equal to sigma y divided by the factor of safety whole square. That is what the maximum strain energy theory is all about. You have to calculate this factor of safety now. Sigma 1 you already know, mu you already know, everything you know. You just have to do some calculation. That is all you have to do. Now who will give me the answer of this question? Like, share and subscribe also, dear students. Whosoever is watching this lecture, like, share and subscribe. Waiting for the answers, waiting for the answers. I am giving you sufficient time, don't worry, but I am waiting for the answers. Waiting for the answers. Okay, so Samir is getting 1.84. Okay, Rahul is saying the level of question. Okay, way of expression. Okay, so that is a different thing. Rahul, just मेरे को answer चाहिए. I want the answer of this question. I want the answer of this question. What is the answer of this question, Rahul? One eight eight five. Achha, 1.85. Okay, 1.85. Okay. Okay, somebody is saying 1.85, somebody is saying 1.84. Okay. Okay. Anyone else? Anyone else? Anyone else? Apart from it, anyone else? otherwise obviously I have to solve it. Okay, now let us directly put the formula, right? Now let us directly put the formula. So if you look at this formula, now what is this sigma 1 now? So sigma 1 is equal to, let us say sigma 1 is 120. Let us say it is 120. So 120 square plus sigma 2 is what? That is your tensile 60. That is 60 square plus sigma 3. Sigma 3 is again 30. So minus 30 square or 30 square, same thing. Minus 2 times of mu. Now what is this mu? Mu is what? Mu. That is your 0.25 given here in the question itself. Into 0.25. In bracket we have sigma 1 is tensile. So tensile, let us say, is positive again. So 120 into sigma 2, that is also 60, again positive, and plus sigma 2 plus 60, and into it will be negative. So plus minus 30 into 60. Why negative? Because it is given as compressive. So it will be minus 30. Okay. And here again minus 120 and into 30. It should always be less than or equal to sigma y. Now what is the sigma y given? Sigma y is 250 megapascals, which is given here, right? So that will be equal to 250 divided by the factor of safety, 250 divided by the factor of safety whole square. So if you calculate it, ultimately, if you calculate it, it will come out to be 120 square plus 60 square plus 30 square minus 2 into 0.25 into bracket 120 into 60 minus 60 into 30 into 120 into 30. So if you calculate it, it will ultimately come out to be 18 or 18,000 to be more precise. It is coming out to be nearly 18,000, right? It is coming out to be nearly 18,000. That is your 18,000. It is coming out to be 18,000, right? So 18,000, it should be less than or equal to what? It should be less than or equal to 250 divided by factor of safety whole square. 250 divided by the factor of safety whole square. So what will be the factor of safety now? The factor of safety, it should always be, you can say, less than or equal to, let us say, for example, because we have to get an exact value, it should be equal to 62500. 25 will be equal to 625 and 00 divided by 18,000, divided by the 18,000. So it will be equal to what? 0 here. So 62.5 divided by 18, 60, not 62.5. Yes, correct. So 625 00 divided by 18,000 and taking a root of that will ultimately come out to be 1.86, will come out to be equal to 1.863, will come out to be 1.863. So this is the correct answer of this question, dear students. That is your 1.863 is the correct answer of this question. Yes, Samir, yes, 1.86. Rahul is saying 1.85. हाँ राहुल, आपका भी सही है, almost same. That is your 1.86 is the correct answer of this question. Was there any option given with this question? Any option with this question? No, option was not there. So it was just a NAT type of question. It was just an NAT type of question. The correct answer of this question will be what? It will be equal to 1.863. 1.863. That is the correct answer of this question. Getting it? Okay. चलिए आगे बढ़ते हैं. I hope you have got it, dear students. I hope that you have got it. Is it fine? Is it fine? Like, share and subscribe also, dear students. Okay. So you like, share and subscribe also. Right. You like, share and subscribe also, dear students. Now before proceeding further, let me tell you again a very important thing, dear students. So we have the Testbook Pass. So we have one pass for complete learning. We have more than 100% courses are there. 6,500 that, okay. 38,000 plus selections we have already made. Good expert guidance you will be getting, as well as the good exam strategy will also be there. So we have one pass for a complete learning. चलिए स्टार्ट करते हैं फिर से दोबारा आगे आगे चलते हैं. Next question, this question, who will solve this question? Who will solve this question? A ductile material has a yield strength of 500 megapascal. The principal stresses at a point were calculated to be 130, 130, 130. Everything is same, 130, 130. As per the distortion energy theory, the factor of safety is what? As per the distortion energy theory. Where is this? Yeah, this one. Try to calculate. Try to calculate it. So what is the formula for distortion energy, right? Distortion energy is what? Distortion energy is what? So that is very simple, right? That is your sigma 1. So distortion energy is a new concept, by the way. So बाकी तो हम लोग पढ़ ही चुके हैं strength of material में, right? So sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 whole square and plus sigma 3 minus sigma 1 whole square. It should be equal to 2 times of what? SYT, or the yield strength in tension, divided by the factor of safety whole square. That is what the formula of the distortion energy theory was, if you remember it, right? So this was the formula, because every scientist has its own approach. Some people are saying that, okay, if maximum shear stresses are exceeded, I will calculate to be as a failed structure. Some people are saying, no, if the maximum principal stress limit is reached, I will say that this thing has failed. So every scientist has a different theory, okay? So who will give me the answer of this question? Samir is saying 0. Okay, Samir is saying 0. Now see, sigma 1 equal to sigma 2, sigma 2 equal to sigma 3, sigma 3 equal to sigma 1, right? And all are tensile in nature because nothing is mentioned about which type of sign is there. So 0, 0, 0. So we have this 0 is equal to 2 times of SYT divided by the factor of safety whole square. Now what will the factor of safety? Because 2 cannot be equal to 0, obviously this should be equal to 0. If this should be equal to 0, SYT cannot be equal to 0. It means that the factor of safety should be equal to some value so that you are getting 0 on the right hand side. So the factor of safety will be equal to what? It will be equal to 1 upon 0. And 1 upon 0 is what? That is your infinity. So factor of safety comes out to be infinity. That is what the correct answer will be. So 4 will be the correct answer of this question. That is 4. Infinity it will be. Infinity, because 0 is coming on the right hand side or on the left hand side, right? That is what it is. So 0 is coming either on the left hand side or on the right hand side. So something divided by 0 is infinite. Something divided by 0 is infinity, right? Okay. So factor of safety should be equal to infinity. If you put infinity here, then only it will come out to be equal to 0. Otherwise, it will not. If you put it as 0, it will come out to be infinity. 1 upon 0 will be equal to infinity, right? Next question. This question. The stress component at a point in a material is given by this 2D stress tensor. It is okay. The yield strength of the material in tension is 400 megapascal. The factor of safety as per the Rankine's theory. Rankine's theory, we have to find the factor of safety will be what? As per the Rankine's theory. Who will give me the answer of this question? Again, a very easy question. So sigma 1 is equal to sigma 2 here. So sigma 1 is equal to sigma 2 here. It is equal to 200 megapascals. It is. So 400 divided by the factor of safety, simple. So factor of safety will be equal to what? The factor of safety will be equal to 4 by 200 will ultimately come out to be equal to 2. So 2 will be the factor of safety of this question. That is B will be the answer, Alisha. Yes, very good. Like, share and subscribe also, dear students. You like, share and subscribe also, so that the other students, they also come to know that there is something, they also get benefited. You like, share and subscribe also, dear students. सो डियर स्टूडेंट्स, यू लाइक शेयर एंड सब्सक्राइब ऑल्सो, सो दैट बाकी बच्चों को भी पता चले कि क्लासेस वगैरह चल रही हैं, ठीक है, और उनका भी जो है फायदा हो जाए हम लोग. This question is an easy question. You can calculate this question. I'm not going to solve this question. Let us move to some other question, which I think that it might be a little bit difficult. If Tresca yield criteria is obeyed. Okay, yeah, try to solve this question. Try to solve this question. This question. What will be the answer of this question? Try to solve this question. इस क्वेश्चन को सॉल्व करने का ट्राई कीजिए आप लोग. Try to solve this question, dear students. This question, dear students, so there was some network issue, I guess. Okay, so somebody is saying 300 megapascals. Okay, somebody is saying 300 megapascals. Okay, what about others? Okay, now let us understand it, right? So what was the Tresca's theory? Tresca ने क्या बोला? Tresca ने बोला कि जो आपका maximum जो आपका yielding होगा वो कब होगा आपका? A body starts yielding, right? So कब होगी आपकी yielding? So according to Tresca yield criteria, we must have SYT divided by 2 times the factor of safety. Remember it? This was the Tresca criteria. It should be equal to, now here 250, 50 minus 50. So we have 3 dimensions given, sigma 1, sigma 2, sigma 3. 3. It should be taken as maximum of sigma 1 minus sigma 2 divided by 2, comma sigma 2 minus sigma 3 divided by 2, comma sigma 3 minus sigma 1 divided by 2. So maximum of these 3. Okay, so what is this? My SYT, that is what I have to calculate. This is my sigma 1 now, this is my sigma 2 now, and this is my sigma 3 now. So with the help of this I can find the maximum value of this, right? Okay, so sigma 1 minus sigma 2, that will be 100 divided by 2 will be equal to what? 100 by 2 is 50. Sigma 2 minus sigma 3. Samir is getting 300. Very good, Samir. Very good. Very good. Yes, very good, Samir. That is a perfectly fine answer. It is. Perfect answer, Samir. 300. Like, share and subscribe also, dear students. Like, share and subscribe also. Next question. Let me read this question first of all. The yield strength of material is equal to sigma over T as per the von Mises theory, the area of the safe region. This is very simple. No need to calculate it also. Cubical block of side. This is also simple. You can solve it. Let us move forward. This is also simple. Let us move forward. Yeah, let us move to this question, this concept now. Let us move to this chapter now. That is the deflection of beams. Okay. अब deflection of beams में चलते हैं. Let us directly start solving some questions. Consider the given statement, the given system as shown in the figure. Find out the value of x required such that the net deflection at the point A, this is the point A, right, is 0. The net deflection is 0. So you have to find the value of x in such a manner. Who will give me the answer of this question? Waiting for the answers. So आपको बहुत इजीली सॉल्व कर सकते हो, राइट? तो मैं थोड़ा सा आपको हल्का सा आइडिया देता हूं हाउ टू सॉल्व इट. सो दिस इज माय 10 acting here. Okay, 10 kilonewton acting here at a distance of, you can say, 2 meters from here. So this beam can be broken into two parts, and plus we can have one more beam here. We can have one more beam here, and at this point, that is this point, we have a load acting, which is this one, that is your 5 kilonewton is the load acting along with the moment. The moment will be in the anti-clockwise manner here. Anti-clockwise it will be going, right? See, here it is going anti-clockwise manner about this point, anti-clockwise manner. That will be equal to 5x. That will be equal to 5 into x into kilonewton meter. So we have broken up this, you can say, beam into two equal parts now, right? Now the deflection due to this load should be equal to deflection due to this load, then only the total deflection will be equal to 0. Okay, now how to calculate the deflection? From the moment area diagram. Okay, the moment area diagram you can get the deflection. Okay, so but this thing we already know, PL cube upon 3I. For example, if we have a cantilever beam somewhat like this and you are applying some load P here, the deflection at this point, the maximum deflection del max is coming out to PL cube upon 3EI. That you already know. That is the PL cube divided by 3 times of E into I. That you already know. So PL cube upon 3EI, right? So we can directly calculate PL cube upon 3I. That is your 10 into 10 raised to the power 3 Newton into L cube. Now what is this L? 2. So 2 cube divided by 3 times of EI. Is EI given to me? No, EI is not given to me. Even if EI is not given to me, it is a constant and ultimately I can cancel it out, right? Minus the deflection due to a moment. If you have a cantilever beam somewhat like this and some moment is applied, the deflection is given by ml square upon 2 EI. That you must be knowing. That is given by ml square upon 2 EI. That will be equal to minus 5 into 10 raised to the power 3 into x into L square. Now what is this L square? L square is 4 divided by 2 EI divided by 2. Okay, it will be equal to 0. If you solve it further, if you further solve it, 10 raised to power 3, 10 raised to power 3, 8, and it will be equal to 2. It will be equal to 2. 10 into 2 is 20 divided by 3. 20 divided by 3 is equals to 5x divided by 2. So it will be equal to 5x divided by 2 is equal to 20 divided by 3, 6.67. 6.67. Now what will be the value of this x? X will be equal to 6.67 into 2 divided by 5. So 6 into 2 is 12. 12 is 13 point something aa jayega. That will nearly come out to be 2.67 meter. The value of x will come out to be nearly 2.67 meter. Yes, 2.67. Very good, Samir. Very good. Very good. 2.67 meter is the correct answer. So if you are providing that load at a distance of 2.67 meter from the beam, the deflection will come out to be ultimately equal to 0. You can also solve it with the help of, yes, Alisha, very good. You can also solve this question easily with the help of strain energy method also, but that will be a lengthy method. So why to, you can say, fall in the prey of a lengthy method? So let us not adopt the question with the help of a lengthy method. Let us try to solve it with an easy method itself. That is the moment area method. So moment area method is a very easy method. The correct answer of this question will be 2.62. So 2.62, 2.62. Now what is the correct answer? 2.6, what is the correct answer coming? What is my correct answer? Okay, 2.67, okay, not 2.62, 2.67 is my correct answer. So 2.67, that is my fourth is the correct answer of this question. Important. And these types of questions, dear students, are very important. So important question it is. Let us move to some more question now. This question. For a simply supported beam under the load as shown, the moment equation to be used in Macaulay's method for calculating the deflection at any point x, distance from a left support A is given by. That is what it is. So we have the double integration method, but double integration method has a lot of limitations. That is, it can be only used for symmetrical load etc etc, और भी बहुत सारी limitations है उसकी. उसके बाद फिर मैकॉलेज मेथड हमारे पास आया था. मैकॉलेज मेथड से आप उसको इजीली कैलकुलेट कर सकते हैं. कोई भी किसी भी अनसिमेट्रिकल लोडिंग को भी आप जो है काफी इजीली कैलकुलेट कर सकते हैं. Okay, there might be confusion, dear students, in this question. The question is that, sir, what are these things? What are these things, right? So there might be a mistake in this answer, dear students. This thing is not you can say less than or greater than. This is what is called as a bracket. It is a type of a bracket. Okay, so just try to you can say understand it. This is a type of a bracket. It is. Now what is the answer to this question? बहुत ही सिंपल है ये वाला, मैं दोबारा बताता हूं आपको. ठीक है, तो क्या बीम है आपके पास? दिस इज द बीम गिवन टू यू. 20 and this is some beam given to us. Here we have this 20 kilonewton, and then we have this UDL here. Then we have this UDL here. The intensity of this UDL is what? It is your 12 kilonewton per meter. That is the 12 kilonewton per meter. This is 334. This is 3 meters. This is also 3 meters, and this is my 4 meters. This is my 4 meters. Okay, now first of all, let us calculate the value of A and RA and RB. So RA plus RB will be equal to 20 plus 12 into 4. So 48 plus 20 is equal to what? It is equal to 68. But taking the moment about B is equal to 0. Taking the moment about B equal to 0. So what it will be? It will be equal to RA 437 RA into 10 minus 20 into 7 minus 12 into 4 into 2 is equal to 0. So RA will be equal to 140 plus 48 into 2 is 96. 140 plus 96 will be equal to nearly, and divide by 10 will be nearly what? 236 divided by 10 is 23.6. That will come out to be 23.6 kilonewton. That is my RA. If you put your RA in this equation, you'll be getting the RB. RB will be equal to 68 minus 23.6. It will ultimately come out to be RB will be equal to 44.4 kilonewton. 44.4 kilonewton. Now in Macaulay's method, what is the concept of Macaulay's method is that you have to take a section X such that all the loading it comes into picture. No loading should be left. That is what the advantage of Macaulay's method is. So if I take X somewhere here, then all the loadings will come into picture from this X. if you take this x from here. So if you take this x from here, the moment at x direction, because we know that E into I into d square y divided by dx square, it gives you mxx. So ultimately we have to calculate this mxx now, right? So what is this mxx? The moment at x section will be equal to 23.6 multiplied by x 0.6 multiplied by x minus 20 into x minus 3 minus 20 into x minus 3 minus 12 into x minus 6 into x minus 6 divided by 2 into x minus 6 and divided by 2. So if you further solve it, the mxx will come out to be 23.6 into x minus 20 times of x minus 3, 6 times of x minus 6 whole square. That is what the value of mxx will be at a distance of x from the left end. Now let us move to the options. Options क्या बोलते हैं? 44.x, it is rejected. 23.x minus 20x, 23.x minus 20x minus 6 plus 60 minus x minus 3 and minus 6 x minus 6 whole square minus 6 into x minus 6 whole square. Yes, this is the correct answer, dear students. This is the correct answer of this question. Yes, this is the correct answer. 23.x minus 20 times of x minus 3 and minus 3. No, this is also not correct. So 2 will be the correct answer. Dear student, this thing and this thing, it is some typographical mistake is there. These are the brackets actually. These are the brackets. Okay, please don't mind now. So this thing and this thing, these are the brackets actually. So this is like this. This is like this. Okay, these are the brackets. This thing. These are the brackets, dear students. Please don't mind now. Okay, so that was the answer of this question, dear students. So have you got it? Have you got it? Shall we proceed further? आगे बढ़े हम लोग आगे बढ़े क्या? RA is coming out to be RB 44.4. Yes, very good, Samir. Very good, very good. Then we have to use the Macaulay's method. ये Macaulay's method क्या है? Macaulay's method double integration method का एक advanced version है. The double integration method has a limitation, that is you can use the double integration method only for the symmetrical loading, otherwise it will be very difficult for us to use the double integration method because we do not know at which point because we do not know the boundary conditions actually, that is at which point you will get a zero slope and at which point you will get a maximum theta u. We do not know all these things, the boundary conditions in case of an unsymmetrical loading. So that is why we use the Macaulay's method. Macaulay's method is a very lengthy method, but questions which are generally asked in examination are just like this. For example, just we solve this question, that is what is the expression for moment in case of the Macaulay's method is being used. So that is how you use the Macaulay's method moment. That is how we calculate. तो जितनी भी लोडिंग है आपकी बीम के ऊपर, सारी लोडिंग जो है कंसिडर करनी पड़ती है Macaulay's मेथड में जब आप बेंडिंग मोमेंट के लिए एक फॉर्मूला बनाते हो, ठीक है. So that is what the Macaulay's method is. Now let us quickly move to the next question, dear students. This question. Now who will solve this question? Consider the beam AB as shown in the figure. Part AC of the beam is rigid while part CB has the flexural rigidity EI. Identify the correct combination of deflection at the point B and bending moment at A. Now who will give me the answer of this question? Very easy. Very easy. Waiting for the answers. बताइए मुझे इसका आंसर क्या होगा. आई एम वेटिंग फॉर द आंसर्स. बताइए बताइए बताइए. Okay, option A. People are saying option A. Yes, option A is the very good, very correct answer. Option 3. Option 3 will not be correct, Samir. Now see. Now see here. See here, this is a rigid beam. Let me change the color of the marker here. ये आपकी ना रिजिड बीम है, दिस इज अ रिजिड बीम, राइट. सो अगर ये रिजिड बीम है तो यहाँ पे डिफ्लेक्शन कैसी आएगी? अगर यहाँ पे लोड आप लगा रहे हो तो ये तो हिलेगा ही नहीं वहां पे, इट विल नॉट मूव बिकॉज इट्स अ रिजिड बीम, राइट. So deflection will come from this. So we have the deflection from this, like this, the deflection. Now it means that this will behave as a support because it's a rigid thing. Deflection, that is your PL cube divided by 3EI. This L will be what? This L will be of this L. This is the L. Acting at this point will be equal to what? P into L plus L, that will be equal to 2PL. So 2PL will be the moment acting at this point and the deflection will be PL cube upon 3I. So 1 will be the correct answer of this question. So 1 is the correct answer, dear students. Next one. Now this question you can solve. I'm not going to solve this question. You can solve this question. Apart from it, now let us move to the next chapter directly because otherwise we will not have sufficient time left. Let us directly move to the next chapter. Yeah, theory of columns, right? Let us move to the directly next chapter, that is the theory of columns now. That is my 7th chapter. Question number 1 in theory of columns. Consider two axially loaded columns as shown below. The ratio of the buckling load in the column AB to that of the column CD is what? So one is a hinged, right? Somewhere here it is hinged. The column number 2, it is supported from here also as well as supported from here also. Dear students, now if you have a column which has been supported from here also and which has been supported from here also, ultimately what will happen is that this particular support will behave as a rigid support then, because this particular column will not be able to move in this direction as well as move in this direction. So what will happen is that this support will behave as a rigid support for this particular column. So that is a very important concept, by the way, right? So this column will behave as a rigid column, that is your from fixed from both the ends. So here also it is fixed and here also it is fixed, but it will behave as here it is fixed and here it is hinged. So now what will happen? The ratio of the buckling load in column AB to that of CD will be equal to what? Now who will give me the answer of this question? Now nothing is left in this question. Who will give me the answer of this question now? So we know that the buckling load is given by pi square EI divided by L effective whole square. That is what the formula of buckling load is. In case of this column, when one end is fixed and the other one is hinged, we know that the L effective is given by L divided by under root of 2 in this case. And when we have both the ends fixed, the L effective is given by L divided by 2, simple, L divided by 2 here. Now if you put it here, so for the first column, that is your column AB, it will be equal to 1 divided by 2, it will be equal to 2 pi square EI divided by L square. For column CD, it will become equal to pi square EI. Now read this question very carefully. Here we have 2 EI. Remember this thing. Here we have 2 EI. Divide by L divided by 2 whole square. It will be equal to 2 into 2 is 4 into 2 is 8. That is 8 pi square EI divided by L square. Can I divide all these? Yes. So PAB, that is the buckling load of AB, divided by the buckling load of CD will be equal to 2 divided by 8 directly. It will be equal to 8 into 2 is 16 and 4, 8 into 5 is 20. So sorry, 8 into 5 is 40. Yes, correct. So 0.25 will be the correct answer of this question. Who has got the answer as 0.25? Yes, 1 by 4 will be the correct answer. Alisha, it should have been 1 by 2, but it is given as 2i, right? It is given as 2ei. So that is why 1 by 4 will be the correct answer. That is your 0.25 will be the correct answer of this question. If it was not given 2ei, obviously that was the correct answer of that question. Yes, very good. I hope that you have got it. Is it fine, dear students? Is it आया आपको ये वाला समझ में आया? Have you got it? Like, share and subscribe also, dear students. You like, share and subscribe also. You share with your friends also. So whosoever is not able to watch, then he or she also watches it and also do the preparation. So समझ में आया आपको? Have you got it? Have you got it? Shall we proceed? Shall we proceed further? Shall we proceed now? Okay, चलिए आगे बढ़ते हैं. चलिए. Next question. This question. Uniaxial compression test data for a solid metal bar of length 1 meter is shown in the figure. Okay. The bar material has a linear elastic response from O to P, followed by a non-linear response. The point P represents the yield point of the material. The rod is pinned at both the ends, the minimum diameter of the bar, so that it does not buckle under axial loading before reaching the yield point is what? So that is what is given. A good question it is. A good question it is. A calculative question. So P, it is given as 0.002. It is given in 100 megapascals. For Q, it is 130 megapascals and it is given as 0.005. So that is what it is given here. Some data is given. A bar, I'm again repeating it, a bar material has a linear elastic response from O to P. It has a linear elastic response followed by a non-linear response. The point P represents the yield point. This represents the yield point of the material. The rod is pinned at both the ends. So we have you can say rod which is pinned here also, and the rod is pinned here also. So it means that the L effective will be equal to L simple, because it has now become a column of both ends hinged. So L effective will become equal to L. The minimum diameter of the bar, so that it does not buckle. It does not buckle. It means that the buckling load should always be greater than P square EI divided by L square. That is what the buckling load should be. Okay, it should be equal to this. Of point should be equal to what? Now give me the answer of this question. Waiting for the answers. वेटिंग फॉर द आंसर्स, वेटिंग फॉर द आंसर्स. आराम से आप आंसर दीजिए, मुझे इसका कोई प्रॉब्लम नहीं है. यू गिव मी द आंसर ऑफ दिस क्वेश्चन. आराम से आप मुझे इसका आंसर दीजिए. आई डू नॉट हैव एनी हरी. तब तक धीरे धीरे इसको मैं भी सॉल्व करता हूं इसको आगे. ओके, लेट मी ऑल्सो ट्राई टू सॉल्व इट लिटिल लिटिल. सो let me change the color of the marker. Let me take it as yellow. Okay, now we know that the buckling load is given by pi square EI divided by L effective whole square. But here in this case, L effective will become equal to L. What do I don't know? Do I know the value of E? No, I do not know. Do I know the value of I? No, I don't know. Do I know the value of L? Yes, I know. Apart from it, I do not know anything. E will be equal to what? E comes out from the stress versus strain curve, right? So what is the stress? So stress, if you see, that is equal to 100 and strain is 0.002. That is 100 divided by 0.002. it will ultimately come out to be what? It will come out to be nearly 0.5 into 10 raised to the power. So this was megapascals. So megapascals it was. Let me multiply it with 10 raised to power 3 also, so that it becomes pascals. Okay. So 3 into 3, 6 and 7, 8. We have 11. Nearly 11 will be here. So 0.5 into 10 raised to power 11 pascals will be the answer. Okay, for this. ओके चलिए अब आगे बढ़ते हैं हम लोग. उसके बाद क्या निकालना है अपने को? देन वी नो दैट द बकलिंग लोड इज इक्वल टू सिग्मा इनटू एरिया. इट विल बी इक्वल टू सिग्मा इनटू पाई बाय 4 into d square. So what it will be equal to? It will be equal to 100, okay, 100 into 10 raised to the power, it will be equal to megapascals, so it will be equal to 6 will be equal to pascals, okay, and into pi by 4 into d square. Pi by 4 into d square will be the buckling load. So that is what I have got an expression of the buckling load in terms of a diameter, right? Now let me apply the Euler's hypothesis or Euler's formula. I will be getting 10 raised to the power, here if you see it, it will be 6 and 7, 8, 10 raised to the power 8 multiplied by pi by 4 into d square. It should be equal to pi square ei, that is your pi square into e 0.5 into 10 raised to the power 11 pascals into e into I will be equal to what? Pi by 64 into d raised to the power whole 4 divided by L is 1. L is given as 1, right? Of length 1 meter. L is given as 1 meter. 1. Now from if you solve it, d square gets cancelled out. It will ultimately come out to be d square here, right? So it will be equal to d square will be equal to, so pi by 4 and pi by 64, it will be equal to 16 here. So 16 is coming out to be here. It will be equal to 16 will go at the top. So 16 will be at the top and divided by, we have this pi square into, this will be equal to 8, 9, 10, 11 into 10 raised to the power 3 and into 0.5. That is what ultimately will be. And d will be equal to what? In meters, it will come out to be under root of 16 divided by pi square divided by 1000 and divided by 0.5 and taking a root of it, it comes out to be 0.0569 meter. 0.0569 meter, or to be more precise, it can be written as 56.9 mm. So diameter is coming out to be what? 56.9 mm. That is what I am getting. That is what I am getting. I am getting the diameter as 56.9 mm. आप लोग का आंसर आया? किसी का आंसर आया इसमें से? Has anybody got the answer? The answer which I am getting it is 56.9 mm is the answer which I am getting. Yes, diameter is 0.0569 meter. Yes, very good, very good, very good, very good, Samir, very good, very good, very good. So diameter is coming out to be 56.9 mm. Yes, perfect, 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 fantastic. Yes, perfect. So that is how you can solve it. Is it fine? Is it fine? Is this question fine to you? Shall we proceed now to the next question? Was this question fine? Shall we proceed to the next question, dear students? Shall we proceed to the next question, dear students? Okay, now let us move to the next question. Let us move to next question. Let us solve one more question from this. Now, a strut of length 5 meters. Strut is also a type of column, but it can also handle some horizontal load also, right? So column is a purely compressive member. Strut can also have some bending moment and something. Okay. Now, a strut of length 5 meters is fixed at one end and the other at the free end is free. The Ehlers buckling load is 50 kilonewton. If both the ends of the strut are fixed, what will the Ehlers buckling load include? That is a very simple question. You can answer this question, but still try to give me the answer. It is a very simple question. A strut of length 5 meters is fixed at one end and the other end is free. The Ehlers buckling load is 50. In this case, the Ehlers buckling load was 50. Okay. Now, if both the ends of the strut are fixed, what will happen? Now, in this case, the buckling load is 4 times the hinged case. Right? In this case, the buckling load is what? It is you can say not 4, but it is divided by 2. Yes, it is divided by 4 times of the hinged case, right? Okay. So the correct will be what? It will become 16 times the case. The total difference will be 16. Okay. So 16 total difference, 16 times it will become. So what will the Ehlers buckling load here? So Ehlers buckling load in this case, it will become equal to 16 times of 50. So what is this 16 times of 50? 16 into 5 is 80. That is your 800 kilonewton will be the correct answer of this question. So without even calculating it, you can say that 800 will be the correct answer of this question. That is C is the correct answer of this question without even calculating it. Yes, very good. Without even calculating it, you can say that 800 will be the correct answer without even calculating. Yes. Next question. Now see, a column clamped at both the ends has a buckling load of 400 Newton. Clamp means hinged, right? During the course of service, one of the ends gets detached from the clamp and becomes a free end. The magnitude of percentage change in buckling load due to the change in the end condition is what? What is the magnitude of change in load due to the change in load condition? That is also a very simple question, by the way, but still I'm waiting for your answers. That what is your answer in this case? What is your answer? Initially it was clamped. Somebody saying it is 75. Okay, what about this? What about others? Try to calculate once more, Samir. Is it correct which you have calculated? या कुछ उसमें mistake हो सकती है. Alicia is also saying 75. Okay, let me try to see whether it is a 75 or something else. Okay. Now, what is the buckling load? The Ehlers buckling load is given by pi square EI divided by L effective whole square. That is what the Ehlers buckling load is, right? Okay. Now, if both the ends are clamped, so we know that the Ehlers buckling load is inversely proportional to L effective whole square. Clear? That is what it is. If both the ends are clamped, right? Oh, sorry. That is my mistake, dear students. That is my mistake. Clamped means fixed. Sorry, that is my mistake. I thought that it is just a pinned thing, right? It is not pinned thing. Clamped means it is fixed, right? So it is also fixed from here and it is also fixed from here. Sorry, that is my mistake. Okay. So clamped means fixed from both the ends. So that is the meaning of clamped. Now you try to calculate the question. Now you will get the answer. So try to calculate it, because that was my mistake. I told you that it is a, you can say that thing. Okay, now you tell me what is the answer of this question. That is my mistake. Clamped means fixed from both the ends. I told you it is hinged. It is not hinged, it is fixed from both the ends. So if both the ends are clamped, we have the L effective is equals to L by 2, right? If both the ends are clamped, we have this L effective is equal to L by 2. Remember it, that is your L by 2 whole square. And if one end is clamped and the other is free, if one end is clamped, other is free, because in this question is written that, okay, detached from the clamp and becomes a free end. If one end is clamped and the other is free, then your Euler's buckling load will become equal to 1 upon you can say 2 times of L whole square. That is what ultimately it will become. Now if you divide it, if you also divide it, ultimately you will be getting 1 by 16 as the correct answer. So P1 upon P2, that will be equal to 1 by 16 as the correct answer, which you will be getting. Now P1 minus P2 divided by P2 into 100 will be equal to what? Or P2 minus P1, the mod of it, right? The mod of it will be equal to 15 divided by 16 into 100. Now what is this 15 divided by 16 into 100? So 15 divided by 16 into 100 will come out to be nearly 93.75. That is your 93.75%. So 93.75% will be the correct answer of this question. Clear? चलिए आगे बढ़ते हैं. A lot of questions you can solve, but now let us not solve lot more questions. This Rankine you solve it. Rankine, because even I feel that कि जो Rankine जो formula है वो बहुत important है exam के लिए. You try to solve this question, Rankine's rule or the Rankine's formula. You try to solve this particular question. Again, it is a very easy question, but still you try to solve it. So Rankine's formula is valid for the intermediate columns which can fail in buckling as well as in crushing. That is for those columns only the Rankine's formula is valid. Now you try to solve this question. क्वेश्चन को सॉल्व करने का ट्राई कीजिए आप लोग. Five, 4, 5. Okay, somebody saying 5, 4, 5. So that is a very easy question. Yes, very easy question, Samir. Yes, Samir, that is an easy question. So what we know is that 1 upon the load in the Rankine, it is equal to 1 upon the crushing load and plus 1 upon the Euler's load. That is what we know. Okay, Euler's load is 1000, crushing load is 1200. कुछ बचा ही नहीं इस क्वेश्चन में, nothing is left. So P Rankine will be equal to 1 upon 1000 and plus 1 upon 1200. So if you ultimately solve it, Rankine or the Rankine load will come out to be 1200 divided by 2200. So it will be equal to 2200 will get cancelled out from here. Ultimately you will be getting nearly, let me write the answer, nearly you will be getting 545, nearly 545 kilonewton you will be getting. Okay, so that is what the correct answer of this question will be equal to. That is 545. So A is the correct answer of this question. Yes, Alisha, A is the correct answer of this question. Next question. Now this question, try to solve it. Good question. The buckling load P is equals to PCR for the column AB in the figure as KT approaches infinity. What is the KT? The torsion spring of stiffness KT. Now if the spring stiffness becomes infinity, what is the meaning of that? It means that at that time it will become as a fixed support. It will become as a fixed support. Then you have to find the value of alpha. Now what will the value of this alpha? You try to give me the answer. Okay, somebody is saying 4. So 1 will become fixed, but 1 is always, you can say, hinged, right? This will become fixed now. Why? because we have the stiffness, right? बिकॉज ये जो आपने लगाया है ना यहाँ पे, ये जो टॉर्शन जो आपने लगाया है, स्प्रिंग ऑफ स्टिफनेस, ये आपने इसी एंड पे लगा हुआ है, तो अल्टीमेटली क्या होगा, अल्टीमेटली दिस एंड विल बिकम स्टिफ, और यू कैन से दिस एंड विल बिकम फिक्स्ड, दिस एंड विल एक्ट एज अ फिक्स्ड एंड, बट दैट एंड विल बी अ हिंज्ड एंड, राइट? सो व्हाट विल हैपन इफ वन एंड इज फिक्स्ड and the another end is hinged? Now what happened to this load? The L effective becomes equal to L by root 2. L by root 2. Now if you do the square of it in the denominator, in the numerator it will reach out to be as 2, right? So 2 will be the correct answer of this question. That is 1 will be the correct answer. Yes, correct. Yes, A. Image is not visible clearly. Okay, that might be one of the cases. Yes, but 1 is the correct answer of this question. Okay. Okay, let's leave this question. Now let us try to solve increases this. Now this is also an easy question. You can solve this question also. You can solve Euler's theory, crippling load. You can solve this question also. It is a theoretical question. Hollow cylindrical cost of this also you can solve. Hollow is also very easy. It is almost similar. The stud of 3 meter length and 4 centimeter in diameter. One of the end is fixed and the other end is hinged. You can solve this question also. That is very easy question. Now let us move to the next chapter. Now what will the answer of this question, dear students? So we have started with the new chapter, that is the torsion, right? Torsion. So under torsion, brittle materials generally fail. Number 1, along a plane perpendicular to its longitudinal axis. Number 2, in the direction of minimum tension. Number 3, along surfaces forming a 45-degree angle with the longitudinal axis. And number 4, not in any specific manner. Who will tell me the answer of this question? Now let me give you a hint. Along a plane perpendicular to its longitudinal axis. Along a plane perpendicular. Okay, somebody is saying along a plane perpendicular to its axis. Let me give you a hint. Ductile materials, the hint is that ductile materials, right? The ductile materials, they generally fail in shear. I am again giving you a hint. The ductile materials generally fail in shear and brittle materials are weaker in tension. I have given you a hint. The ductile materials, they fail in shear and the brittle materials are generally, you can say brittle materials generally fail in tension, right? Okay. Brittle materials are weaker in tension. I have given you a hint. Yes, very good, Samir, very good, right? So I was expecting this answer, right? Now, if this is the hint which I have given to you, now what will the answer of this question? Because that was just a hint, right? What will happen is that when subjected to a torsion, right? When subjected to a torsion, a brittle material will break along a surface which is at an angle of 45 degree to the shaft axis. A brittle material. As far as the ductile material is concerned, it will fail at a plane perpendicular to the shaft axis. So that is the difference between the two. Because a ductile material, it generally fails in shear. So remember this thing. So I had given you a hint, right? So the correct answer of this question is option number 3 is the correct answer of this question. Option number 3. This one is the correct answer of this question. Next question. A circular cantilever beam is subjected to a torsion at the tip. Because of the tension, the angle of the twist is found to be 0.5 degrees, the angle of twist as shown in the figure. So this is what the, even if you do not know what is shown in the figure, just remember this thing, that angle of twist is 0.5 degree, right? The length of the beam is what? Take R is equal to 100 mm and phi is equal to 0.1 degrees. So we have to find the length of the beam. So there is a relation, let me give you a hint, there is a relation, that is arc length, that is your S, arc length, let us say it is S, right? So S is given by R into theta, R into theta is the arc length, and R into theta should be equal to L into phi. R into theta should be equal to L into phi. The arc length should come out to be equal, right? It should come out to be equal, the arc length, right? Okay, it should be coming out to be equal. So that should the arc length. Now applying these two concepts, now because if you have a rod, right, let us say that you have a rod somewhat like this. अगर आपके पास एक ऐसी कोई rod है like this, if you have a rod somewhat like this, if you apply some torque, let us say this is the angle theta, this is the angle theta, okay, and this is the length, something is L. So L into this angle phi will be equal to R into theta. That is for common, because my arc is common everywhere, right? So R into theta will be equal to L into phi. So what will be this L? L will be equal to R into theta divided by phi. L will be equal to R into theta divided by phi, simple, right? So what it will be? It will be equal to 100 into theta, because theta is very small, so I can take it in radian directly or degree directly, whatever it is, right? It will be equal to 0.5 divided by, why 0.5? It is given as 0.5, the angle of twist, okay, and the shear angle is given as 0.1 divided by 0.1. So it will be equal to 10, not 10, it will be equal to 5, it will be equal to 500 mm will be the length of the shaft. 500 mm will be the length of the shaft. Let me see your answers also. 500. Yes, Alisha. Very good. Very good. Yes, very good. So 500 will be the correct answer of this question. That is, here you will have 500 mm. I hope you are getting it. Right? Is it fine, dear students? Is it fine? Have you got it? Is it fine? Like, share and subscribe also, so that the other students, your friends, they also come to know that something is going here on this channel, and we have very good quality of questions, by the way. These questions you will not find, right? So yes, 500 is the correct answer, Alisha. Very good. Chaliye aage badhte. Let us move forward now. Next question. Which of the following state of stress show torsion in shaft? Torsion. Which of the following is showing torsion? Who will give me the answer of this question? Very easy. This is very easy, right? Due to torsion, shear stresses will be generated. I have given you a hint also. Due to torsion, shear stresses will be generated. Now, what will be the answer of this question? Waiting for the answers. 4. Somebody is saying 4. A. Alisha is saying A. Okay, good. Yes. Because if you are applying some torsion, right? If you are applying some torsion, shear stresses will be generated. If you are applying some torsion T, shear stresses will be generated, and this will be the correct answer of this. That is 1. If you are also applying some moment also, agar aap koi moment bhi laga doge, if you are applying some moment also, then this will be the correct diagram. If you are applying some moment also, but here no moment is being applied, only this will be the correct answer of this question. That is 1 is the correct answer. Now this one, a solid circular shaft of diameter D is subjected to a combined bending moment of M and torque. The material property to be used for designing the shaft using the relation, this thing is what? Ultimate tensile strength, yield tensile strength, torsional yield strength, या endurance strength. So which is the correct answer of this question, dear students? Yes, three. So that is not even no need to explain you, right? So 3 is the correct answer of this. So if the combined torsion is given by under root of m square plus t square is the combined torsion, okay? And the torsion, due to torsion, shear stresses are generated, right? So shear stress should always be less than or equal to what? SSY. That is the torsional shear stresses or the torsional yield strength. It should always be less than or equal to torsional yield strength. So 3 will be the correct answer of this question. Yes. Next question. Next. Question this. A hollow circular shaft has an outer diameter of 100 mm and inner diameter of 50 mm. If the allowable shear stress is 125 megapascal, the minimum torque that the shaft can resist is what? Again, a simple question, but you try to solve it. You have to give the answer in the nearest integer. Clear? You have to give the answer up to the in the nearest integer, whatever the nearest integer is. Like, share and subscribe also, dear students. You like, share and subscribe also. Mukesh is saying 23. I don't know the answer, Mukesh. I have to calculate the answer, then I will see the answer also. Samir is saying 230. Samir is saying 230. In kilonewton meter. Okay, Samir is saying 230. Now let us try to solve the question also. Let me take a blue, not blue, yellow pen here. So we know that from the torsional formula, so we same as we have the torsional formula, we have the flexural formula, right? The torsional formula is, that is the torque divided by the polar moment of inertia, that is your T by J, is equal to tau divided by R is equal to G theta by L, G into theta divided by L. So in this question, what else is required? So is this required polar moment of inertia? Yes, it will be required. Is this required or not? It will not be required. Only tau by R, this thing is required. Okay. So now tau max is given to us as what? The tau max is given to us as 125 megapascals. That is your 125 megapascals. So let me put 125 here. So it will be equal to 125 divided by the radius of the shaft. Now how much is the radius of the shaft? Now without even doing this thing, let me calculate the polar moment of inertia. The polar moment of inertia will be equal to pi by 32 and it is a hollow shaft. So outer diameter whole 4 minus inner diameter whole 4. So that will be equal to, outer is what? 100, inner is 50. So 100 raised to the power whole 4 minus 50 raised to the power whole 4. That will be the polar moment of inertia. Clear? Now what will be this torque? Maximum torque. So maximum torque will be equal to tau into J, that is 125 into J. Now what is this J? J is your pi by 32 into 100 raised to the power 4 minus 50 raised to the power 4 and divided by the R. Now what is the value of this R? R is equal to, outer diameter is 100, so radius will be equal to 100 divided by 250, because we always take this R from the outer diameter, not the inner diameter. Remember this thing, right? So it will be equal to what? or you can say it will be d2 minus d1. R will be equal to the outer thing will be equal to what? D2 minus d1 divided by 2. That will also be the total, be the fine, right? So it will be equal to 50 here. So ultimately what you will be getting is that you will be getting 125, okay, into 100 raised to the power 4 minus 50 raised to the power 4 comes out to be this thing, and divide by 50 into pi into 30 divide by 32, it will come out to be, and divide by 50, it will come out to be nearly I am getting because here I have to multiply it with 10 raised to power minus 6 also, because the answer which is asking in kilonewton meter, but this will come out to be in mm, right? So mm and Newton mm, so Newton mm, they are 10 raised to power minus 6. Ultimately my answer is coming out to be 23.09, so not 23, 20.009, 23.009 kilonewton meter. Or to be more precise, because I have to find up to the nearest integer, it will be 23. So 23 will be the correct answer of this question. That is 23 is the correct answer of this question. Yes, 23. Yes, 23. Mukesh is saying 23. Yes, Mukesh, it was 23. Very good, very good. Yes, Samir, 23. Yes, Samir, 23 was the correct answer of this question. 23 is the correct answer. Are you enjoying it? Are you enjoying it, dear students? Are you enjoying it? Is it fine? Is it fine? आपको समझ में आ रहा है ना? Are you getting it or not? Are you getting it or not? Yes, 23, Alisha. Are you getting it, dear students? आपको समझ में तो आ रहा है ना? Are you really getting it? चलिए next question. Before proceeding further, let me tell you a very important thing, dear students. So you can go for the Testbook Pass, dear students. So we have one pass for 100% courses. 6,500 plus mock tests are there. 38,000 plus selections we have already made in various competitive exams. Good expert guidance you will also be getting, as well as the good exam strategy videos are also there. So we have one pass for a complete learning. Okay, students, so as you know that on YT, on YouTube and other open platforms, we cannot discuss a lot of things in a lot of details, okay, because it takes a lot of time. But obviously on the Testbook Select, you can say platform, I'm discussing each and everything in a lot of details, okay. So whatever we are discussing right now, I have already taught all these things to the students actually, okay. So if anybody of you is interested in buying, you can say, because that is a paid course, by the way, but because if anybody of you is interested in buying the course, so he or she can enter Varun and a capital of K. This is the referral code, and you will be getting a flat discount of around 20%. We have a very marginal, you can say, cost is also there, and plus you will be getting a flat discount of 20% also. Let us move to the next question. Try to solve this question. Try to solve this question. ओके, मुकेश इज आस्किंग समथिंग। सर मेरे को एसएससी जेई का प्रिपरेशन करना है 2021 वाला। हाँ मुकेश, आप अच्छे से तैयारी कीजिए, यू प्रिपेयर योर सेल्फ, राइट, यू डू अ गुड प्रिपरेशन मुकेश। Okay, so what else you want to ask? Yes, you do preparation. If you want to, you can say understand the concepts from me. Then you can go to the Testbook official channel and you can also enter my code. Also, you'll be getting a discount also. So मैं वहाँ पे daily classes लेता हूँ. I am taking classes 9 AM in the morning और मैं जो है दोपहर में भी क्लास लेता हूँ वहाँ पे. So already हमारा काफी सिलेबस हो चुका है. Strength of material हम फिनिश कर चुके हैं. Structural analysis हम फिनिश कर चुके हैं. We have also we have almost finished the highway engineering portion also. एंड रेलवे इंजीनियरिंग मंडे से स्टार्ट हो जाएगा, कल से रेलवे इंजीनियरिंग वहां पे स्टार्ट हो जाएगा. एंड आफ्टर दैट, आफ्टर दिस ट्रांसपोर्टेशन पोर्शन, द लास्ट थिंग दैट विल बी डिस्कसिंग वाज विल बी after this we'll be discussing about the irrigation engineering, hydrology and irrigation. That is also very interesting topic for SSC JE point of view. Alicia is saying D. Okay, Alicia is saying D. A solid steel shaft is surrounded by a copper shaft. Okay, then such that J steel is equals to, means that the polar moment of inertia of the steel is equal to this. Okay, now modulus of rigidity of copper is half of modulus of rigidity of steel. What is the ratio of torsion in steel upon torsion in copper? If composite shaft is subjected to a twisting moment, a composite shaft is supposed to getting a twisting moment. Now let us understand this question. First of all, let us understand what is a composite shaft. Composite means parallel, right? Now what is the composite shaft? Composite shaft. Now what is a composite shaft? So dear students, this type of shaft where we have the outer cladding to be as copper and the inside we have the steel, that is said to be as a composite shaft, right? So this type of shaft is said to be as a composite shaft. This one, outside we have this copper and inside we have this steel, that is my composite shaft. So a solid circular shaft is surrounded by a copper shaft such that J of steel is this, G of steel is this. Okay, so we have to find TS upon TC. So we know that theta will be same, simple. If it is a composite shaft, theta will be same. If it is a parallel, if it is a series shaft, T will be same. Theta will be same. If theta will be same, then your TS into LS, that is the torsion in the steel shaft into length of the steel shaft divided by modulus of rigidity of steel into the polar modulus of steel, it should be equal to what? TC into LC divided by GC into JC. Simple. Okay. Now LC cancel out because we have the same lengths, right? So length will get cancelled out. So TS divided by TC, you will ultimately will be getting GS divided by GC multiplied by multiplied by length will get cancelled out. Okay, multiplied by JS divided by JC. So JS divided by JC. Now what is this GS divided by GC? So GS divided by GC is equal to 2 and JS divided by JC will be equal to 1 by 2. So it will be equal to 2 into 1 by 2 will be equal to 1. So 1 is the correct answer of this question. Yes, Alisha, it is 1. Yes, Alisha, it is 1. So 1 is the correct answer of this question. Yes, 1 is the correct answer. So let us move to the question directly. Yes, so 1 is the correct answer of this question. Very good, everyone. Next question. Next question. This question. A circular shaft is fixed at one end. Here it is fixed, right? If you are not able to see it, let me again draw it. So this is the circular shaft which is fixed here. It is fixed here like this. Like this, it is fixed here. Okay. At the free end as shown in the figure, it is rotated with the uniformly distributed torsion T per unit length along its length. तो यहाँ पे हर point पे मतलब मैं इसको घुमा रहा हूँ. At every point some torsion is applied. Okay. So some torsion is here. So I can also show the torsion like this also, if you know. I can also show the torsion like this also. Okay. That is given as T per unit length. T per unit length. Okay. determine the rotation of the free end if the torsion rigidity of the shaft is GJ. So we have to determine the torsional rotation of the free end we have to determine. Now, who will give me the answer of this question? Okay. You try to solve this question. Just give me 1 minute. Let me take some medicine also. Okay. You try to solve this question. Let me turn off the camera till now. Till then. Try to solve this question, dear students. Try to solve it. Okay. Try to solve this question. Have you got it? Have you got it, dear students? Have you got it? Okay, A. Somebody is saying A. Okay. Option 1. Option 1. Okay, now let us try to solve it. Let us try to directly solve this question. The question is, so we have a torsion, but the torsion is varying, right? So with the section, it is varying with the T per unit length. Now, we know this formula. Now, what is this formula? That is T by J is equal to G theta divided by L is equal to tau divided by R. So this formula we already know. Clear? If this formula we already know, what do we have to find in this question? In the question we have to find a rotation. We have to find the rotation of the free end. So this is varying. This is varying with the distance. It is varying. Okay. So we can say that d theta divided by dx, because with respect to x I am calculating, right? D theta divided by dx will be equal to torsion. Now what is this torsion? The torsion is varying, right? So that is T into x. At any section x, if you consider any section x, let us say this is the x I am considering, here it will be T into x, right? So small t into x divide by g into j. That is what it will be. So d theta will be what? D theta will be equal to T into x divided by g into j into dx. Doing the integration for the whole length of the shaft, ultimately what we will be getting is that the total theta, because here also integration, the total theta will ultimately come out to be t will be here x cube, sorry, it will not be x cube, it will be equal to x square divided by 2. So putting the upper limit as L, it will be equal to L square divided by 2 times of G into J. So this will be the correct answer of this question. So TL square divided by 2GJ. So TL square divided by 2GJ. Yes, you people are correct. So 1 is the correct answer of this question. Very good, everybody, very good. Yes. Next question. Try to solve this question. The cross section of two hollow bars made of the same material are concentric circle as shown in the figure. This is something, okay. So here we have this R2, the way we have this R2, this is my R2 here, okay, and this is my R1 here, this is my R1 here. Similarly, I have my R4, this is the outer is the R4 and the inner is the R3. Cross section are the same. J1 and J2 are the torsional rigidities. J1 and J2 are the torsional rigidities of the bar on the left and right respectively. The value of J2 upon J1 is what? Okay, J2 upon J1 is value is what? Greater than 1, less than 0.5, equal to 1 or between 0.5 and 0.1. That is the question which it is asking. And R3 is greater than R1, R4 is greater than R2. That is what it is there. Directly I can write J2 upon J1 will be equal to G, okay, the polar moment of inertia, okay, the polar moment of inertia will be equal to what? Let me write it here. What is this J actually? So J is the, this J is the, you can say, or you can say that the modulus of rigidity, or torsional rigidity to be more precise, that is your, because I want to solve this question in as short method as possible. Torsional rigidity is defined as the product of the modulus of rigidity and multiply the polar moment of inertia. So torsional rigidity will be same for both the shafts, for both the cases, because it is given in the question itself, right? The torsional rigidities of bars on the left, on the right are respectively same. So they have the same torsional, J1 and J2 are the, so not same, we have this J1 and J2. So J1 and J2 are the torsional rigidities of the bars on the left and on the right. For this we have this J1 and for this we have this J2. So now, what is the value of J2 upon J1? Now J2 upon J1 will be equal to what? It will be equal to G into the polar moment of inertia of the second shaft divided by G, the polar moment of inertia of the first shaft, because the modulus of rigidity is given as same, right? Same material. So same material, we have the same modulus of rigidity. Clear? Now what will it be equal to? It will be equal to, GG gets cancelled out from here. It will be IP2 upon IP1 only. It will be equal to, in terms of radius, the polar moment of inertia is given by pi by 2 R4 raised to the power whole 4 minus R3 raised to the power whole 4 divided by pi by 2. Then we have R2 raised to the power whole 4 minus R1 raised to the power whole 4. That is what ultimately it will be. Or you can say that J2 upon J1 will be equal to pi by 2 gets cancelled out, R4 minus R3 raised to the power whole 4 divided by R2 minus R1 raised to the power whole 4 raised to the power whole 4. That is what it will be, okay. Now something else is given here. Now what else is given? Two circular shafts or two hollow bars are made of the same material, concentric circle as shown in the figure. It is given that R3 is greater than R1, R4 greater than R2, and that the areas of the cross section are same. That is also given. That the area of cross section is also same. Now dear students, if the area of cross section is same, what will happen is that R2 square minus R1 square, because pi by 4 into R2 square minus R1 square will be equal to R4 square minus R3 square. Now I can dissolve this particular expression in a square minus b square term. Ultimately I will be getting these two things at the numerator and the denominator, which will be ultimately cancelled out. Why? Because it is actually equal, right? So ultimately I will be getting what? Ultimately I will be getting J2 upon J1. Only plus term will be there, negative will be cancelled out. R4 whole square plus R3 whole square divided by R2 whole square and plus R1 whole square. That is what ultimately we will be getting. Okay, that is what ultimately we will be getting. Now something is given in the question, R4 is greater than R2. Now see here, R4 is greater than R2, R3 is greater than R1. Let me write it here also. R4 is greater than R2 and R3 is greater than R1. So this is given in the question. That is, both numerator terms are greater than the denominator terms, right? That is, both numerator terms are greater than the denominator terms. What does it mean? It means that J2 divided by J1, okay, this value will be what? This value will be greater than 1, right? So it will be what? It will be greater than. Simple. So that is the correct answer of this question. Alisha is saying A. Alisha is saying A. Let us see. Yes, Alisha, A will be the correct answer of this question. So greater than 1 will be the correct answer of this question. Very good. A will be the correct answer of this question. That is because this thing is given, right? R4 is greater than R2, R3 is greater than R1. It means that both the numerator terms are greater than denominator terms. Obviously, the ratio will be greater than 1. Simple. Have you got it? Have you got it, dear students? Have you got it? Is it fine? Is it fine? Option 1. Yes, Samir. It was option number 1. Yes, very good. Yes, very good, very good. Have you got it? Is it fine, dear student? Is it fine? Shall we proceed now? Now let us proceed to the next chapter directly, because other questions you can easily solve. A machine element, you can solve this question, an easy question it is, okay? This was also, but let us move to the next chapter. Otherwise, we will not be able to, you can say, to complete all the chapters. So let us move to the next chapter. That is the thick and thin cylinders and spheres. Let us move to this chapter. Find out the solution of this question. The maximum shear stress in the plane of a stored gas cylindrical tank of inner radius 5 meter and wall thickness 30 mm. The gauge pressure of the gas is 1 megapascal. The maximum shear stress in the wall is how much? Now, who will give me the answer of this question? So we know that we have two types of stresses. So first one is the hoop stress, that is given by PD upon 2T. Then we have the longitudinal stress, which is the minor principal stress, that is PD upon 4T. And if you solve these two, so sigma 1, so this was my sigma 1 in this direction. This is, let us say, sigma 1 now. And let us say this is my sigma 2 now in this direction. If you solve it, the maximum shear stress comes out to be PD upon 8T. PD upon 8T, that is what the maximum shear stress is coming out to be. You can directly apply the formula, you will get the answer. Who will give me the answer of this question? B, A. Okay, what about others? Baki ka? PD divided by 4T. Let me try to calculate also, dear students. Now see here. So this is my, let us say here we have this PD divided by 2T, and here I have my PD divided by 4T. Now I have to find the maximum shear stress, right? Let us put a Mohr circle here. Now if I draw a Mohr circle, both are tensile in nature. So this is my PD upon 2T comma 0. This is what is PD upon 4T comma 0, and this is the Mohr circle which I am getting. Now what is the maximum shear stress here? It will be PD upon tau max will be equal to PD upon 2T minus PD upon 4T and divided by 2. So what it will be? The numerator will be equal to 8T divided by 8T divided by 4 minus 2 will be equal to 2. So 2 PD divided by 2. Ultimately it will come out to be what? Let me solve it here. It will come out to be tau max. Tau max will come out to be 4, and it will be equal to PD upon 8T. It will be equal to PD upon 8T. That is what it will be. That is PD upon 8T. Okay. Now let us directly try to solve this question. So tau max will be equal to what? What is this P? P is what? P pressure. Pressure is 1 megapascal. 1 megapascal is the pressure. That is 1 megapascal is the pressure, or you can say 1 into 1000, that is Pascal. Okay. 1 into 1000, let us say it is. Okay. And what is this D? Diameter. Diameter is what? Diameter is what? Inner radius is 5 mm. Diameter will be 10. Inner radius of 5 meter and wall thickness of 5 meters. So into 2 it will be 10 meters. Into 2. Divide by 8 into thickness. Now thickness is what? Thickness is equal to 30. Thickness is equal to 30. That will be equal to tau max. Tau max. It will be equal to what? It will be equal to 10,000 divided by 30 and divide by 8. Comes out to be nearly 41.67. Comes out to be nearly 41.67 megapascals. 41.67 megapascals. That is the correct answer of this question, dear students. Okay, somebody is asking something. If we consider radial shear stress as 0, then the maximum shear stress of PD upon 4T. Let me check the question, whether radial is given as 0 or not. Find the maximum shear stress in the plane of stored gas cylindrical tank of inner radius 5 mm, wall thickness, the gauge pressure of the this. Yes, if you take one of the shear stress, if you take the radial shear stress 0, it will be ultimately equal to PD upon 4T. But we are not taking the radial shear stress equal to 0. So if we have a tank, let us say a cylindrical tank or whatever it is, so some pressure will be acting here and some pressure will be acting in this direction also, some pressure will be acting. So in both longitudinal direction as well as the lateral direction, some pressure will be acting, and the total shear stress will come out to be equal to PD upon 8T. If one of you are, if at least one you are taking at 0, for example, in case of you can say it is a cylindrical tank, by the way, it is a cylindrical tank. If you are considering some other cases, both will come out to be equal. If you are considering some other case, both will come out to be equal, right? For example, in case of a sphere, the hoop stress becomes equal to the longitudinal stress. Okay, so there we have a different case. For that we have a different case. Next, this question: the value of hoop strain induced in a thin spherical. Now this is a spherical shell. It is a spherical shell of diameter 70 mm is 0.35. Okay, under the influence of internal pressure, the magnitude of volumetric strain for the same shell at the same internal pressure is what? So we know that epsilon V in case of a spherical is equal to 3 times of epsilon H. I have given you a hint. This we already know, because in case of a sphere, all the stresses acting in all the directions are equal. So strain will also be equal, and strain equal to epsilon x plus epsilon y plus epsilon z, and all are equal, so it will be 3 times of epsilon H. will be the correct answer. Okay, epsilon h is given to us 0.35. Epsilon v will be equal to what? It will be equal to 3 into 0.35. It will be equal to 1.05. So 1.05 will be the volumetric strain. 1.05 will be the volumetric strain. Now what it is asking me in the question? In the question it is saying that the magnitude of volumetric strain is, oh, very simple, it is just 1.05. I did not read the question carefully. It is just asking me volumetric strain only. It will be 1.05 only. No need to worry at all. Yes, 1.05. Yes, very good, Alicia. 41.67. 1.05, 1.0. Yes, very good, very good. Everyone. Yes, very good. Very good. Everyone. Yes, very good. Like, share and subscribe also, dear students. Okay, Mukesh is also saying 1.05. Okay, very good. Yes, 1.05 is the correct answer. Let us move to the next question. This question. In a thin cylindrical shell, D by T ratio is 50. It is subjected to an internal fluid pressure of 2.5 megapascal. What is the maximum hoop tension developed in the cylinder? So we have to find the maximum hoop tension. Again, a very simple question, dear students. I am waiting for your answers. Very easy question. (62.5) option 1. Option 1. Yes, that is very easy question actually. This question you can easily solve. So we know that the hoop stress is given by PD upon 2T. So PD upon 2 times of T. D by T is given to you. D by T is what? That is 50. So P is what? 2.5 megapascal divided by 2 into 50. So it will be equal to 25 into 2.5 will be equal to 62.5. Simple. No need to calculate even. So that is 61. 1 is the correct answer. You're getting it? Getting it? Are you really enjoying it, dear students, or it is just a burden for you? Really enjoying it or not, right? And like, share and subscribe also. You share with your friends also, dear students, so that they also get benefited. Okay, Mukesh is enjoying. Okay, what about others? Is it fine, dear students? Is it fine? Are you getting it what I am saying? Okay, are you really getting it? चलिए आगे बढ़ते हैं हम लोग. चलिए आगे बढ़ते हैं. Okay. Let us try to solve steel hub of this thickness more headed toward this also you can solve, dear students, but let us try to solve this question. So solve this question. A steel hub of 100 mm internal diameter and uniform thickness of what? The uniform thickness is this much. 10 mm was heated to a temperature of 300 degrees Celsius to shrink fit it on a shaft. On cooling, the crack developed parallel to the direction of the length of the hub. The cause of the failure is attributable to. That is a theoretical question. I have explained this question very well in the classes also. One, okay, one person, one student is saying 1, okay, Samir is saying 1, okay. Yeah, that is very simple, right? Because we know that in case of a shrink fit on a shaft, tensile stresses are developed, right, which are more than the radial stresses, and that is the hoop stress. So hoop stress is actually developed, that is the tensile hoop stress. That is a very simple theoretical question it is. That is A will be the correct answer of this question. Simple. इसमें तो कुछ करना ही नहीं है अपने को. That is the A will be the correct answer. That is a simple question. You can solve this question. You can solve. It's very good. This also you can solve. Let us move to the next chapter. A thin cylindrical, then the change in dimension. This also you can solve it. This is also you can solve. A closed thin cylindrical pressure. This is also you can solve. A cylindrical pressure vessel diameter. This is subjected to this is also you can solve it. The easy question. A thin cylinder with both ends subjected to ordinary pressure per. This is also you can solve it. That is an easy question. Okay. A spherical pressure vessel of inner diameter, if the yield stresses, this is the factor of safety. This is also you can solve it. Don't need to worry at all. Then we have, okay, now let us move to the next chapter. That is the last chapter of this series that we have today discussed. That is the chapter number 10, strain gauges, rosettes and springs. Solve question number 1. Compute the strain hardening component N for an alloy in which a true stress of 415 megapascal produces a true strain of 0.10. Take the value of K as 1035 megapascal. Who will solve this question? Who will solve this question? So we have to find the strain hardening component, right? We have to find the strain hardening component. Now the question is, what is the strain hardening component? So first of all, now let me tell you, we know that sigma T is given by K into epsilon T raised to the power N, right? Okay. Or let me take the logarithm on both sides because this N will come here. So that is log of sigma T will be equal to log of K plus N log of epsilon T. Log of epsilon T. What will be the value of this N? N will be equal to log of T minus log of K and divided by log of epsilon T. So that is what the value of N will be equal to, which is also called as the strain hardening exponent. That is called the strain hardening exponent. The question is, sir, ये कहाँ से आया derivation? That is a very well versed derivation. I have already explained in my classes. Okay. So epsilon T is equals to K into epsilon T raised to the power N in the strain hardening zone. That is what is happening. So this formula was given by, I don't remember the name of the scientist, but remember the formula was given. Okay. So now you can just directly put it. Now what will the value of this N? N will be equal to log of 415. Why 415? Because here it is given. That is 415 megapascals. Log of 415 minus log of 1035. Why 1035? Because it is given as the value of K is 1035. Log of 1035 divided by, we have this log of epsilon T. Now what is this log of epsilon T? That is log of 0.1 or true strain. Further solve it, N will come out to be 0.397. I am directly writing the answer because I know the answer. So the answer directly will be equal to 0.397. Yes, very good, Alisha. Very good, very good, very good, Alisha. It will come out to be 0.396 or 0.397 nearly. That will be the correct answer of this question. Yes, very good. So the correct answer of this question will be what? It will be equal to 0.397. Next question. For some metal alloy, a true stress of 345 megapascal produces a plastic true strain of 0.02. How much will a specimen of this material elongate in mm when a true stress of 415 megapascal is applied if the original length is 500 mm? Assume a value of 0.22 for the strain hardening exponent N. Now who will give me the answer of this question? Again, let me write the same formula. That is your sigma T will be equal to K into epsilon T raised to the power N. Let me directly write the formula, right? Okay. Now, if you take the logarithm on both the sides, okay, then you will be getting, and K is a constant, N is the strain hardening exponent that I have already told you, K is a constant. Now, what else is given? 0.22 for strain hardening constant. This N value is given to us as 0.22. So, we will get 345. Why 345? It is given as 345 here, right? So 345 will be equal to K into 0.02, because it is given the strain, right? The true strain is 0.02 raised to the power 0.22. So if you solve it, the value of k will come out to be equal to 345 divided by 0.02 raised to the power 0.22. It will come out to be ultimately 815.8. The value of this k will come out to be 815.8. 815.8 megapascal is the value of k. So we have got the value of k here, that is my 815.8 megapascal is the value of k. Now let us move forward now. Now we know that now what else is given? It is given as 415 here, right? It was given as 415 कि 415 के corresponding आपका जो epsilon t है वो क्या होगा? It is asking me that thing. So 415, again applying the same formula, 415, because now I know the value of this k. You can also divide it also, you will get the answer. There is no need to calculate the value of k also. You write down two equations, you divide it, k will ultimately get cancelled out. That is also you can do. So it will be equal to 815.8. But just to make you sure how do we calculate the value of k, I have calculated it, right? So that is 815.8 multiplied by epsilon t, which I don't know, epsilon t raised to the power 0.22. The value of epsilon t from here, it will come out to be nearly 0.046. 0.046. I'm directly writing the answer because I have the answer sheet with me. I'm directly writing it, 0.046. Now applying the basic concept of the logarithmic strain, that is my L upon L naught, it is equal to e raised to the power, because ln of L upon L naught is equals to this 0.046. If you take anti-logarithm here, it will come out to be e raised to the power 0.046. Ultimately, you will be getting 1.047 will be the value of L upon L naught, or you can say that L will be equal to 1.047 multiplied by L naught. Now what is the value of this L naught here? So L naught is already given to us, right? L naught is already given to us in the question itself. Now what is the value of this L naught? That is 500 mm. So 500 mm is the value of this L naught into 500. Ultimately it will come out to be 523.54. That is the value of L, which is coming out to be 523.54. Now what will the value of L minus L naught? The value of L minus L naught will be equal to 500 minus 523, that is your 23.54. Simple, directly I am writing it. 23.54 will be the correct answer of L minus L naught. 23, yes, very good. Everyone. Samir, yes, 23. So 23.54 is the correct answer which I am getting. That is 23.54. So the correct answer will be what? It will be equal to 23.54 mm will be the correct answer of this question. I hope you have got it now. Is it fine, dear students? Is it fine? Is it fine? Is it fine? Have you got it? Like, share and subscribe also with your friends so that they also come to know कि यहाँ पे कोई revision चल रहा है with numericals. Okay, you like, share, subscribe also. And before proceeding further, dear students, let me again tell you a very important thing. The students who are watching this lecture for the very first time. So we have a textbook pass. So we have one pass for complete learning. We have more than 100% courses accessible with that textbook pass. We have more than 6,500 plus mock test. A lot of selections we have already made. Expert guidance you will also be getting, as well as the good exam strategy videos are also available on the platform. So that is why we say one pass for complete learning. And the price of this textbook pass are very, very nominal, very marginal. These are the prices. Okay, students, so if anybody of you is interested, because we cannot discuss almost all the things in a lot of details here on an open platform, because it takes a lot of time, right? Even one concept takes 30 minutes or 40 minutes to understand deeply. If anybody of you is interested कि मेरे को एकदम deep में समझना है किसी concept को, you can go to the Testbook channel and buy whatever you want to buy for you, right? Because I am already teaching there strength of material structure analysis and other subjects also. Okay, so you can also enter my code. My code is Varun, 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 and a capital of K, right? Kumar. So the first letter of this Kumar is K. So Varun K, and you will be getting a flat discount of around 20%, because these are the paid courses, students. So obviously, if you are paying something, if you are getting some discount, obviously that is a benefit for win-win situation. Okay, so dear students, now let us move forward to some other questions. This question. Now, who will solve this question? Following data of a rectangular strain gauge rosette. So we have various types of rosettes. We have the rectangular, we have the star pattern, we have the triangular pattern. A different type of rosettes are there, right? But here some angle is given. En theta 0, it is given 90, it is given 45. So three angles are given. Okay, so it means that one is rosette is at somewhere here, one is at an angle of 45, and one is at an angle of 90 degree. So we have this type of rosette system here. Now what we have to do is that you have to find the epsilon 1. You have to find this epsilon 1. How much will be the value of this epsilon 1? So who will give me the answer of this epsilon 1? Again, these rosettes questions, if you know, the rosettes questions are a little bit lengthy questions. Okay, so remember this thing. Let us say this is your epsilon A, this is your epsilon B, and this is your epsilon C. So rosette questions are a little bit lengthy questions, but still we will try to solve these questions. You also try to solve it. I am also trying to solve it. Okay, now this is what it is given. You note down the values, then we will one by one we will solve these questions. You also solve it, I will also solve it. (23.156 mm). Yes, it was correct, almost correct. You also try to solve it, dear students. I am also trying to solve it. We both will solve it together, because rosette questions are a little bit lengthy questions, but not very difficult, but lengthy questions these are. Okay, now let us try to solve it. So first of all, epsilon n theta is given to us as what? That is your at 0 degree. At 0 degree it is given as, let us say, epsilon A. Okay, so I have written here epsilon A, that is your, let us say, epsilon 0 degree. This is my epsilon 45 degree, and this is my epsilon 90 degree, for example. This is my epsilon 90 degree, for example. This is my 45 degree, this is my 90 degree. So that is what values which I have given it: epsilon A, epsilon B, and epsilon C. Now see here, epsilon 1 2, we know that epsilon 1 comma 2, it is given by epsilon x plus epsilon y divided by 2 plus minus under root of epsilon x minus epsilon y. What is the epsilon 1 and 2? That we have to find principal, right? Epsilon x minus epsilon y divided by 2 whole square and plus gamma xy and divided by 2. This is the very common mistake which students are making. That is, they are not dividing it by 2. बहुत ही common mistake है exam में, ठीक है ना? Divide by 2. So now epsilon A is equal to 1200 was something. It was 1200 something. This was 1200 something. This is 80, 800, 1200, 800, and 400. Okay, 1200, 800, 400. So it is equal to what? It is equal to 1200 plus 800 divided by 2 plus minus under root of 1200 minus 800 divided by 2 whole square and plus, now what is this gamma xy divided by 2? Now gamma xy here, it is coming out to be what? That is coming out to be gamma xy, we have to find it, right? Gamma xy we have to find it. Gamma xy we have to find it. Now gamma xy is not given. Now let us say this is your x by 2 square. Now if you have find this thing, answer will be solved. Now ultimate aim is to find this gamma xy. Now we also know that gamma xy will come out to be equal to 2 epsilon b, because here you see this, right? Here you see this resolution, 2 epsilon b minus epsilon a minus epsilon c, right? 2 epsilon b minus epsilon a minus epsilon c, 2 epsilon b minus epsilon a minus epsilon c. Let me check it again. 2 epsilon b, yes, correct, minus epsilon a minus epsilon c, yes, correct. Okay, so that will be equal to what? That will be equal to 2 times of epsilon b is 400 minus epsilon a is 1200 and minus epsilon c is 800. Okay, 800, and this will be equal to what? This will be equal to, in bracket close, into 10 raised to power minus 6. That will be equal to what? It will be equal to minus 1200 into 10 raised to the power minus 6 is gamma xy. Is gamma xy, which is coming out to my equal to x, which is my x. So in this equation, the previous equation, I have to put it as minus 1200 divided by 2. Simple. Now it is simple, right? So let me put it here directly. So it will be equal to what? It will be equal to 1200, 800, 2000 divided by 2 is 1000. Directly it is 1000. Okay. So 1000, and we have this plus minus. I will take only plus because I have to find epsilon 1, not epsilon 2. It will be equal to under root of 100, 400 divided by 2, 200 square, that is your 400. 200 divided by 2, let us say it is 400 divided by 2, that is 200 square. So 200 square and plus we have the 600 square. Why 600 square? Because it was 1200, right? It was 1200. That is why it is 600 square. And 10 raised to power 6, obviously we will have 10 raised to power minus 6 also here. 10 raised to power minus 6 also will be here. Here also 10 raised to power minus 6 will be here. 10 raised to power minus 6 will be here. So everywhere we will have 10 raised to power minus 6. If you solve it, ultimately you will be getting 1632.45 into 10 raised to the power minus 6. That is what my epsilon 1 will come out to be. That is the value of epsilon 1 it will be. Samir, 2.216, it is 1632.45. Please check where you have done the calculation mistake. Please check it. Please check it. Where have you done the calculation mistake? You will come out to know. Because we know that the strain rosettes can also be explained, or the strain rosettes can also be expressed in this form also. That is your epsilon in 2D. Epsilon in 2D, they can also be represented in this form. That is epsilon A. Then we have 2 times of epsilon B minus epsilon A minus epsilon C, and here also the same thing, and divided by 2 also, sorry, divided by 2 also, and here also 2 times of epsilon B minus epsilon A minus epsilon C, and divided by 2 here also, and here we have this epsilon C. So this can be represented in this form also. Clear? And from there we had got that, if you remember it. So gamma xy by 2 comes out to be equal to this thing. So gamma xy will be equal to 2 epsilon b minus epsilon a minus epsilon c. From there it is coming out to be. Please check where you have done the calculation mistake, because mine is coming out to be nearly 1632.45 10 raised to power minus 6. This is what I am getting. So everywhere we have 10 raised to power minus 6. Everywhere we have 10 raised to power minus 6. Okay. Like, share and subscribe also, dear students. Have you got it, Samir? आपको समझ में आया, Samir? Have you got it? Hi, Tanmay. Hi, how are you, Tanmay? तन्मय आज तो लेट हो गए आप, आज तो हम बहुत सारा डिस्कस ऑलरेडी कर चुके हैं, काफी कुछ डिस्कस कर चुके हैं आज तो हम लोग। 8 घंटे की क्लास ऑलमोस्ट हो चुकी है सुबह से, इतने तगड़े तगड़े क्वेश्चन किए तन्मय, आप तो लेट हो गए। ओके समीर, प्लीज चेक इट वंस अगेन, कहां पे मिस्टेक हुई है आपसे, प्लीज चेक इट वंस अगेन। आई थिंक दैट यू मस्ट हैव डन सम कैलकुलेशन मिस्टेक, because I am getting it as nearly what is the answer which is coming for this question? Answer इसका आ रहा है 1.632.45 to test for -6. This is the answer which is coming for this particular question. Please check it. What is the mistake which you have done? Okay. Like, share and subscribe also, dear students. You like, share and subscribe also. बाकी लोगों को भी पता चले ताकि कुछ चल रहा है यहाँ पे, आप इसको लाइक शेयर एंड सब्सक्राइब कीजिए डियर स्टूडेंट्स। So let us solve one more question. We'll watch recording to cover up the things. Yes, you watch the recording स्तन में, तो आपको समझ में आ जाएगा, ठीक है। मेरी थोड़ी तबीयत खराब थी यार, थोड़ा गले में प्रॉब्लम थी मेरे, बट आई हैव ट्राइड माई बेस्ट टू कन्वे यू ऑल द थिंग्स एंड आई होप दैट कि आपको समझ में आ रहा होगा, समीर को समझ में आ रहा होगा, जो बाकी लोग काफी टाइम से देख रहे हैं उनको समझ में आ रहा होगा, ठीक है। चलिए आगे बढ़ते हैं। This question you can solve. Again, it is a very lengthy question, right? इसमें क्या है? In a stressed member, two strain gauges are placed at 35 degree. Again, ये strain gauge का question है, बहुत ही lengthy question है. You can solve it. You can take a screenshot of it, and after some time you can solve it at your home. Or if you don't want to take the screenshot also, आप YouTube पे back करना तो आपको question दिख जाएगा. You solve it, okay? You try to solve it. This question also, this is also very lengthy question, लेकिन बहुत easy है. ये भी आपका question जो है easily solve हो जाएगा. This also you can solve very easily. Although it is a lengthy question, लेकिन आपका solve हो जाएगा. Now this, who will give me the answer of this question? Now who will give me the answer of this question? That is a theoretical question, by the way. So we don't have much time left. That is why I am stuck with this. I am not, you can say, मैं इसको आगे नहीं बढ़ा रहा हूँ. तो आप बताइए मेरे को इसका आंसर क्या होगा? What will be the answer of this question? For a given strain gauge, the relative change in electrical resistance to mechanical strain is called as what? Very important, dear students, very important. क्या इसका आंसर क्या होगा? इसका आंसर क्या होगा स्टूडेंट्स? बताइए जरा मेरे को इसका आंसर। Alisha is saying Poisson's ratio. Okay, Alisha is saying Poisson's ratio. इसके अलावा बाकी का आंसर, बाकी का? Alisha is saying Poisson's ratio. Okay, it is a theoretical question, dear students. Always remember that for a strain gauge, right? For a let us say this is a strain gauge, right? Okay, the relative change in the electrical resistance, because we know that कि जैसे जैसे आपका strain gauge खींचेगा वैसे वैसे length उसका बढ़ेगा. If the length is increasing, there will be some change in the resistance also. Okay, because how these strain gauges, they give us the you can say with the help of the resistance, we calculate how much is the change in length actually. Okay, so we have a ratio, that is the electrical resistance to the mechanical strain, and this ratio you have to remember it, that is called as the gauge factor. That is called as a gauge factor, dear students. Very very important. If this question is asked in examination, a lot of students will not be able to answer. I'm telling you that, right? It is very very important. That is called as a gauge factor. Clear? Remember this thing, it is called as gauge factor, because we know that अगर किसी मेंबर में अगर ज्यादा स्ट्रेन आ रहा है, if a member is getting deformed, obviously its resistance is going to change. The resistance of the strain gauge is going to change, and ultimately the computer will show you some different results. So we have a factor that is called as a gauge factor, which gives us that particular thing, that how much is the change of the electrical resistance with the mechanical strain. That is a gauge factor. Okay, is it fine? Is it fine, dear students? Is it fine? Is it fine? I hope that this is fine with you. Let me see some more questions. So this question also, you take the screenshot, this question. Okay, now give me the answer of this question. Concentric helical springs should be wound in same direction, wound with opposite hand helix, could be wound in any directions. Directions of winding depends upon the load to be carried. Now who will give me the answer of this question, dear students? Who will give me the answer of this question? Who will give me the answer? Okay, Tanmay is saying 2. Yes, very good Tanmay, very good. Yes, 2 is the correct answer. So हम लोग क्या करते हैं, जो भी concentric helical springs होते हैं, for example this spring is this which is bound in this direction, जो आपके इसके अंदर जो spring होगा ना वो उल्टी डायरेक्शन में बाउंड करते हैं उसको ऐसे, that is bound in the opposite direction, right? The reason being that if there is some tensile loads acting, there should not be any type of buckling, should not be there, right? So that is why we always wind it in the opposite direction. So that is 2 will be the correct answer of this question. Okay, so yes, very good Tanmay, very good, very good. So we only have 3 minutes left, dear students. Before signing off, let me show you some other questions also. You take the screenshot. So this is one question. You can take the screenshot, or you can go to YouTube session once again and you will find these questions also. This is one question. Okay, this is one more question. It is a very easy question. Equivalent stiffness we have to find of two springs. Do you know for the parallel and for the series which formula do we apply and why do we apply that formula? You know that. Okay, चलिए इसके बाद अगला क्वेश्चन ये वाला है. ये भी बहुत ही इजी क्वेश्चन है, लेकिन ये बहुत ही कंसेप्चुअल क्वेश्चन है स्टूडेंट्स. ये बहुत ही अच्छा क्वेश्चन है ये वाला. इसको सॉल्व करने का ट्राई करना. बहुत ही कंसेप्चुअल क्वेश्चन है ये वाला. ठीक है, आगे बढ़ते हैं अभी हम लोग. नेक्स्ट ये क्वेश्चन भी आप सॉल्व करना. ये भी बड़ा कंसेप्चुअल क्वेश्चन है, वेरी कंसेप्चुअल क्वेश्चन इट इज. यू टेक द स्क्रीनशॉट और यू डू समथिंग एल्स. सो वेरी कंसेप्चुअल क्वेश्चन. यू ट्राई टू सॉल्व दिस क्वेश्चन ऑल्सो. This is also a very conceptual question. Okay, we have a frame ABC consisting of two rigid parts, and then what do we have to find? We have to find the value of delta and theta. Civil people will be able to solve this question much easier, but it doesn't mean that this is only for civil people. This is for mechanical, by the way, right? Okay, so mechanical people will also be able to answer it. If they apply some concepts, they will be able to answer this question also. If the wire of diameter of a compressive helical spring increases by 2%, the change in spring stiffness. We have a formula for spring stiffness. We know that it is directly proportional to d raised to the power 4. You can calculate the answer very easily. Very easy. This strain gauge, strain rosette. This question we have solved. Similar type of question we have just solved right now. Okay. So these were all the questions, dear students. So total today we have solved around 100 questions on strength of material we have solved. So around 100 questions on strength of material we have solved. If not every question, that's some similar questions we have solved in today's class. I hope that this class you were, and like, share and subscribe also, dear students. And I hope that in this class you were able to revise. देखो ये क्लास उसके लिए थी जिसने हल्का फुल्का पढ़ा हुआ था. अगर किसी ने बिल्कुल ही नहीं पढ़ा तो उसको आज की क्लास समझ में नहीं आएगी. मैं दोबारा बता देता हूं. He or she will not get it at all whosoever has not studied strength of material at all. If someone has studied strength of material for the even one time also, he or she will be able to get what I have told in today's class. So dear students, I hope that I was able to clear your doubts. You like, you share, you subscribe also. We will meet at some other day. Till then, best of luck.